then I'll share my second screen here. And we'll go from that. Let me get this out of the way. Okay, so make sure that if you have any questions while we're going along, that you just you know, make sure that you ask and you don't, don't fall behind. If something goes past, stop me and let's make sure we go over everything, that we've got everything that you need to figure out. So we'll start first here with taking a look. First of all, did everybody get the materials? I sent the link for you to get the downloaded data sets and um, the data sets and this training guide. Does everybody have that handy? You know, you've got that because we're going to be using those.
Yeah, I'm downloading it right now. I should have it here in about 2 minutes or
All
30
righty.
seconds here.
Yep.
Uh,
So just put those two folders in a folder that you know how to get to, and that'll be your working location when we work with those. Um, in fact, there's one folder, I think it's called data sets or something like that. That's typically where we'll just work out of that folder wherever you put it. And the other one has the field to finish documentation. That's sort of a catch all from where you got it. Now, those links will stay active um, even after the class. So if you ever need to go back and download a fresh set of all that kind of stuff, just go back, save that email or send me another email and say you'd like to have the link again or whatever, and you can always download this again. Um, so that will be uh, those don't go away. They stay there permanently, and you can always get those and recover some of this if you'd like to start things over. But let's go over a couple of things that are available here um, with the book. Okay, so you have obviously it's a PDF document, and you see it has a table of contents. Well, the table of contents is well, it's supposed to be. There it is. It is um, it is linked. There are active links to each of these sections. So if you go to here about if you wanted to jump down and look at this exercise on adding break lines, for instance, these are, well, I just had it a second ago and I don't know why. There we go. Let's see here. Once if I look at some of these are, I don't know if I may have downloaded a bad version of the file. Anyway, make sure, double check and see if your stuff are, every one of these things should be hot linked. And I'm only getting a few that are popping up. I don't see them. Let me see. You. Me a minute. Let me try this again. I may have something wrong with my file here. Let me see. All right. Let's see. I don't know. Does your all's, do you have, are you seeing that you have this little, see how the link comes up on, say, here's my draw menu.
It looks like I got it on the first page. What was that, page two? I got them all, and then some of them on the next couple. But either way, it'll be easy enough to type in a page number.
Yeah, well, sorry about that. That's nor, I don't know what's, I have to go back and find, that's the original source of that file, so it's probably the same things. The other, see, that page is all good.
Yeah, I'm seeing the same thing you are.
Like, see, this view menu is missing, but this one, edit is okay, draw is okay, but view is missing. Oh, that's unfortunate. Well, okay. Uh, if I can reset those, I'll figure something out and send you guys updates on them if I can figure it out. But right now, we're not going to take up much time here to go over that to try to find that out. All right. So anyway, here's a little bit of my background. And really, it's kind of, this 30 years, this is like my publicity picture. That's really closer to 40 years now. See, I graduated from college in 84. I started working in 82. So yeah, 42 years. I was doing work with a surveyor back in 82 and in my college days, filled that out. But anyway, the point is not to, to be a let's pat Ken on the back because he's done such wonderful things. The point is this last statement right here. Okay. Keep that handy because as part of being a training client of MSoft Solutions, then you have access to us as a resource in terms of technical support. Um, and, and again, we can often be the intercessor, if you will, between you and Carlson, although you do have direct access to Carlson Tech support, which is always free of charge. So make sure that you keep those resources at your fingertips so that you can use them if you need. But anytime afterwards, if you have a question on stuff you're working on, even if it's something we haven't gone over in class, send me an email, give me a call. You've got all of that information in the emails that I've sent to you as well. Um, Keep that handy. If you ever need it, then get in touch. Like I said, even if it's not something we went over in class, I'll be glad to point you in the right direction. If it's something, let's say you come up and say, well, I've got this big project I want to get out. I've got a subdivision I've got to design and get platted and get recorded, and it's going to take, weeks and weeks of time, then we'll talk about doing some consulting with you as a consulting partner, and then you can put us on your project team. I do that quite a lot with several clients. In fact, the one I was telling you about earlier, the retired gentleman, that's one thing that we do constantly. He just sends me a thing. Hey, you got an hour, you got a half hour, you got 4 hours. I need a whole day, and we just do this one on one. And it's sort of like a retainage situation. But if it's something that just takes an hour or so to give you an answer on it, then that's certainly included with just the fact that you're an MSoft customer. And there's no charge for any of that. But if it gets into something that's going to be a long, um, sort of a collaboration, then we'll talk about some more formal arrangements if we need to. But, and I'd say I wouldn't say most clients, in fact, most students, in fact, that's our hope is that you don't need us any further because you've learned all this stuff inside and out and you're running away with it and doing well. So that's the hope. But that resource is there. So make sure that you continue to use that. Okay. Um, a little bit about the book and all of this. All of these little things are typical. This a bit about Carlson Software. Now, this is not about the company. Okay, this is about how Carlson as a software application works. And that's the fact that it's working on this CAD drawing, okay, the DWG file, and it's using that CAD system as the engine to run on top of. Okay, so it could run, it can run on top of any of the AutoCAD branded products like Civil 3D, AutoCAD Map, or just plain AutoCAD. It can also run uh, very well on top of IntelliCAD, which is an AutoCAD. I don't want to say clone. It's not really meant to be a command by command exact copy of AutoCAD, although it does support almost all of the same AutoCAD command structures. But it's a CAD system, and it's included free of charge when you have Carlson software. It's a really, really nice product. In fact, I have access to not only the AutoCAD branded CAD platform myself. I do have that. I have it installed. I've got two different versions. I've got a Mac native version, a Macintosh version, as well as Windows versions. I've got it standalone. I've got it by with a Carlson on top of it. I've got Civil 3D on top of that. I've got MicroStation, Open Roads Designer, and Open Site Designer, which are MicroStation based CAD design systems. And I've got Carlson on top of IntelliCAD. Guess which one I use the most? And it's the Carlson on IntelliCAD. It's seemingly the cheapest. It certainly was nothing more than the cost of the Carlson software, which included the CAD engine free of charge, and I don't have to pay that maintenance fee to the CAD vendor and all that. However, if you do use those other products like AutoCAD and such, um, certainly you can use those, and they work just fine. Okay, so that's what this is talking about. This one page is the fact that all of these commands that you're going to get out of Carlson software is going to really behind the scenes be up front, it's going to ask you for information that you're going to fill out, and then it's going to take that information, and it's going to turn around and go back behind the curtain and say, hey, here, CAD system, here is a bunch of stuff we want to find out. Do what you need to do as a regular old CAD system, and then tell us the answers, and then I'll give those back to the folks that asked the question in survey speak or in engineering speak. So it's really an interface that sits on top of the CAD system, and it's using the CAD engine to do the most of these commands and results. And so here's one of the things that happens is that when you do things like turn a polyline into a center line that you're going to use for a roadway alignment, for instance, or a sewer line layout, then the the element that is in the DWG file is just a CAD entity. It's just a polyline, okay, or piece of line work. However, Carlson's aware of it. Carlson knows about it, but it stores all of its data in external files, so you can always recover those. And this is what what it talks about here is that it does this with the underlying software commands only, and the CAD drawing that you're working with doesn't contain any of these so-called proprietary objects that you might notice if you're working on a file from, say, a Civil 3D. Somebody, a colleague that has done another with another company might have provided that other DWG file, and it has some proprietary objects that you can't get access to. So Carlson leaves everything intact. It's just plain old CAD stuff at the end of the day, but they give you all of these extra tools to help you use those plain old CAD things in putting together your work product. Okay, so that's the heart and soul of how this system works. Now there's a couple of things that we'll talk about in general, and I'm not going to spend a whole lot of time here. We do need to talk about um, some settings. but we also want to talk about how things, where do things go when you run the software? And there's basically this section starting on page 4 of the manual. It talks about this organizing your work, and um, there's this little general modules. If you have more than just Carlson survey, you can switch in and out of those different modules here, and you can see what they stand for there. But the the organization behind where the data is starting here on page 5, and there's several different methods, and you'll see right here is when you do a project setup, you have these 3 choices, either a project folder, a drawing folder, or a fixed folder. Pretty self-explanatory. The project folder lets you come up with a series of folders that you want to see in every project that you do, and then you make assignments into the typical Carlson type of data file. You say, all right, here's this kind of file. I want it to go in this particular folder over here. You have full control over that. You decide what structure you want. You may only have 2 folders, one that says data files and another one says contract files or plots and PDFs and any kind of stuff like that. Uh, and it just builds that structure, and it starts to look for when you go to open those type files or save those type files, it goes back and reads this setup and points you to those locations as a starting point to try to find that information. You can always navigate away from it at any point, but it's just a way to organize your drawing structure. Okay. Now we're going to be working with it in this default condition that says drawing folder. And that's this one here in the middle that you see on this um, image on the screen. And all that means is that it's going to always start wherever the drawing lives. That's going to be your working folder where it's going to start looking for data files. Okay. That's the default. And typically, when you're working on uh, a, in a regular workflow environment, you're going to have your drawing files that you're going to be working with in a particular folder on a particular client's job. And so that's where all those files are going to live together. But if you happen to do every client all in the same folder, then every data file that you ever create is going to at least start out looking at that location to store and retrieve data files from. So it's just a way of telling the software where you want to find the information. Okay. So then we're going to talk a little bit about um, some settings. Let's see here. And I'll go over those really quick. That's really part of the fundamentals class. We're not going to get into a whole lot of this, but we will spend a little bit of time just to make sure we're all on the same page. But there's some things here in the manual that tells you how to go through these different settings explorers and as to what they happen to do. And then we're going to start talking about some points and point groups um, and all that. So now you guys are all surveyors or are in the surveying class. Presumably you're using, data collectors and that sort of stuff. Are you, what do you use in the field? What particular software are you using? Are you using Carlson, Serve PC, or Serve CE?
That's what we're using, Serve CE.
Okay. And how about Brooks? I'm sorry, I can't hear you very well.
Yeah,
You're using Carlson?
yeah.
Okay. So, all right. So when you do that, when you bring these points that you bring out in the field, when you bring them back into Carlson in the office, there's a lot of people aren't aware of the fact that you can just bring in that CRD file directly. A lot of people will export it out as a text file and then import that text file in to the office side. You don't have to go through that step. It's the same file, the CRD file. But in any case, it's a file of points. Okay, and we're going to see how points are going to be very useful with what we're going to be doing based on those descriptions, because it's going to allow us to, as long as we're consistent with the way we pick the information up in the field, we're going to be able to do a whole lot more than just go out there and shoot a point and then bring it back in the office, dump the points into the drawing, and then start playing connect the dots, because sometimes that'll take us a day or two to try to figure out what everything is that we shot and what needs to be connected and what doesn't. Where once we learn how to use these a bit more effectively with, particularly with field to finish, you can come in and a matter at the end of the, you know, maybe a half hour, you've got 90% of a finished mapping product done. And that includes setting things up to be able to model them in 3 dimensions and generate contours and the whole works. It's not just for planimetric stuff. It certainly works for that as well. So that's what we'll start to jump into and take a look at. We're not going to spend a whole lot of time in this class on, there's this, we will look at points and point groups pretty well, but then this surfaces and contours, this terrain modeling, and starting here on page 18, and that's, again, we spend a lot of time of that in the fundamentals class, and in the civil and the 3D data prep classes, we do a lot of that kind of work. We're going to do some of that so you can see it, and there's, but what you're looking at here is starting on page 18 with some background and some discussion, is basically, and then we talk about break lines, and right here's the absolute rule of thumb. If it's an edge out there on the ground, then we need to make it an edge in the model data set, and that becomes a break line, and that helps us do our work. Again, field to finish is going to help us create those on the fly as we go in the field, and you can even see them on your data collector before you come back out of the field, so that you've got things ready to go and you haven't missed some things. Okay, so this little discussion between pages 18 and 25 down before the exercise for break line starts is that's sort of everything you need to know about terrain modeling and how Carlson works with it. And, we're going to, as part of what we're going to go through, we're going to see, a couple of examples of what that's going to do for us. But this class is not going to be real heavy on that part of it. But there's enough exercises up here in your text, in your study guide, all the way down through this last exercise called putting it all together, that steps you through a typical workflow on the modeling side of things. Okay, so you're going to model all the way down, and it shows you, how to do the terrain modeling, and this is an example of a little stockpile, and then this little area here of a little, maybe a borrow pit that you're going to design into this stockpile area, and generate finished contours, and a little design roadway that comes up into that, and you can see there's your finished contours to design that roadway into there. So there's going to be some good information there. Now, what we're going to spend more of our time doing is going to be here, starting with the survey module and these design exercises. So we're going to do some raw file processing, and then some deed tools. Okay. Let me get back up here to find. Right in here. Let's get right here is this field to finish, and this is probably going to be one of the things that I think is one of the greatest efficiencies that the Carlson software offers, those that can use them and use the points, is this idea of field to finish processing. And this is going to take a little sample set of points. We're going to set up our codes, and then we're going to wind up having it generate, a complete finished survey product that should look, something like this. And when that code table is set up and used correctly, this can happen in about 15 minutes. Okay, go from a point file to this in about 15 minutes. Now it'll take us longer than that. We'll take several hours because we're going to work on the codes. We're going to understand what they do. We're going to go through and set up, the necessary information to generate the contours here. And we're going to set this up, you can see the roadway out here as well. Okay, so we're going to go through that pretty well. And then some other examples of, again, a little bit of usage of field to finish and how you can fix a lot of problems. If you can see this data set, you can see the points here. If we don't set up our break lines, for instance, and just do a, sorry, give me a sec. And if we just do a, go through and generate the contours, they're going to wind up looking like this. And you can see that's a mess. But that's what a lot of surveyors will turn in. And they'll say, hey, there it is. So, oh, that's what my point said. That's got to be right. Well, really, when you look at these points, and we'll see that when we get into the exercise, you're going to see if you set up the break line information correctly, you're going to wind up with your contours looking much more like what you would expect. You see there's a ditch around this little raised platform. And you see that with those raised contours, okay? Or those contour, sort of nosed shaped contours. Like over here, it's a real mess, a real hodgepodge, because it's formed the triangles over on these edges formed incorrectly. And we can use field to finish to very quickly go in here and take that data and generate the break lines on the fly. Just have it do it for us. We don't have to do it like we typically would set up. And then we're going to start to get into some of these deed processing tools and how we're going to use it to help generate resolutions from field located points based into our deed reconstructions that we're trying to come up with. And then finally, if we have some time, we can get into this LotNet processing and see how that process works. A couple of things that are sort of prerequisite, have to have a closed boundary and have to have center lines for roadways pre-established and that sort of things. And it will go through and automatically lay out roads and parcels, complete with, setbacks, and you can put building footprints on there with the houses of a certain size if you'd like, generate coordinate tables, curve tables, line tables. So all of those things can happen for us rather automatically. So after that, then starting on page 78 of the manual, there is this command reference, these general menus, and this goes through all of the different commands based on all of the menus going through, and it says right up here, command reference, general menus. So that's going to step you through that file menu, edit menu, which is pretty extensive, then view, then draw, etc. So there's file, edit, view, draw, inquiry, settings, and points. And that concludes all of those general menus. And the next set from those are these surveys. So here's the last of the points menu commands, and they end with that. And then you start to pick up the commands for all of the survey module menus. So these are all of the menus that are to the right of the points menu, starting with the survey menu, okay? And then it's going to take you from there. As you can see, it's going to, and then it goes through the coordinate geometry menu. So Kogo, and then there's a center line, something, let's see, a lot of computation in there. So, but anyway, that's, yeah, there's center line menu. So then it's going to go, survey, Kogo, center lines, profiles, sections. And actually, that's from the civil module here. The area layout would be next, and then annotate would be the one that follows that. Okay, so that's going to show you those commands, and some of them, they're just real short synopsis of how the command works with enough information to find it out. Sometimes it's a really laid out long explanation, complete with some pictures. Here's your surface menu, how that does the computation. So there's a lot of things in there. The Surface 3D flyover, that should give you a good means of, help you go back and learn the software as you're going through it. A lot of that stuff came the from the help system that's available to you all the time, but most of them were it's not just a straight copy out of the help system. It's expanded upon where it needs to be expanded upon, and it's also synopsized into a little smaller chunk if everything else is basically just a bunch of fluff in the help system and you don't really need all that stuff. So it's a nice little reference where um, and that's where you can use this book to help you go through that. Okay. So let's go to the first bit. We're going to talk about, let me go here to page 10 in your book. We're going to talk about some settings. Now, over on the software side of things, go ahead and run your Carlson. And let it come up. We're going to start a new empty drawing or empty file. Okay, so if you have yours configured to come up with your start screen, you're going to see something like this. I would presume that most of you have that if you're using the current, I'm running Carlson 2023 right now. Then this shows me some of my recent documents. And you've got, this is just a front end. You can look at it just by name, by a little icon, little pictures. You've got links to things over here on the sides. And don't forget about these links, for instance. You've got the support, you've got news feeds over here on the side, the tip of the day. All of these things are pretty important stuff. There's even this drawings map. So if you're a large company and you've got drawings, projects that you've done all over the place, you can actually go to like an internet map interface, and you can sort of navigate your way into a city and state and a town or an address within a particular city and state. And then it will show you where your projects are in relation to that location, as long as those projects that you've worked on were done with a known coordinate system, such as state plane coordinates. So if it can be geo-referenced, it's going to show up in that interface. And that's a way to also keep track of your file locations. To be honest with you, I don't use it much because I know, where all my files are, and the work that I do in my regular consulting practice, I'm engaged with them enough that I know where those files are located. So it's not something that I can necessarily use a lot of, but help yourself if you like to do it. But for now, let's go ahead and say a new drawing. So I'm going to click that new drawing button, and you may or may not get this wizard. If you do, just follow through mostly defaults. If you do not, just go ahead and wait till we get into the software until we catch things up. And I'm going to go ahead and choose next, and I'm going to find a template that I like. That's my Carlson, just standard Carlson DWT. I'm going to switch to my Carlson National CAD standards for survey. I'll choose that, and I'll choose finish. And it's going to go through a bunch of things to set up my drawing. And it's going to then ask me for some things to get started with. And right now I've got, things you can see here. I've got a scale. I've got symbol plot sizes and text plot sizes. We'll talk about that in just a second. And then down here to the coordinate system. So I'm going to leave mine set to state plane 83. I can put it on, any of these that I might happen to have. I can give it a project name. Let's call it survey class. The project name and job number 133-456. And project location is in Pittsburgh. Oops, let's spell it right. Okay. And there's a little box right there that says skip the wizard next time. You may have turned that on because you don't like to step through this. That's fine. I find a lot of good, helpful discipline out of this wizard. I like to use it. You may decide later you'd like to use it. And there's only, if you have checked that and turned it off, there's only one place to turn it back on. And we'll see where that is here in just a second. And that's in your general settings. But I'm going to now do it off. And here's one of the reasons I like it. If I say, okay, I filled all this stuff out, I set up my horizontal scale. Let's say instead of 40 scale, I want to make that a 30 scale. Now watch what happens right here. So if I change my scale from 30, it looks at this number here, 0.1. So a tenth of an inch at 1 inch equals 30 feet equals 3 feet on the ground. 0.08, or like a Leroy 80 text size, 8/100ths of an inch at 30 scale is 2.4. But if I make this, say, 50 scale, now what's it? It becomes 5 and 4. If I'm doing a large plat, I'm doing, let's say, a 200 scale, then that becomes 20 and 16. So here's what's going on with that. I'm going to set it back to 30. Is that when I tell Carlson to do a command that's going to generate symbols and text, it's going to have a place in most of the dialogues that are going to ask me for that symbol plot size and the text plot size. And when I see that term plot size or plot size scalar, you'll sometimes see, or text size scalar, think to yourself, plotted inches. Okay, this is like your how big that's going to be on paper if you print it out at that scale. Okay, and so you're going to basically leave those values for certain things that you're doing, like bearings and distances or centerline stationing, whatever. And you're going to set them once, you're going to fiddle around with them and get them finessed into the right way that you want them. And then you're going to leave them alone and they're going to stay there. But then when you change scale of your project, Carlson handles recomputing these numbers, and it's these numbers over here that the CAD system is looking for. So you don't have to constantly do that mental math and answer the question, all right, I want my text to be 2.4 feet tall. And then if you forget what scale you're at, only thing you have to remember is this plotted inches size, and it's going to do that calculation for you. Okay. So we get all that stuff figured out, filled out, and we're ready to go. And I'm going to hit this next button, and you're going to see it's going to give me an error. Okay. Because, hey, you're missing a drawing name. I said, whoa, where was the drawing name? And it's right up here at the very top. And you see, when I get this first dialog box up in my face, it's sometimes easy to overlook. Okay. So that new drawing name, it's waiting for me to tell it a name. I haven't given it a name yet. And so I don't know where it is. Okay. And right now it would go to a default location that's already it's already been set up as to a default, but I'm going to go over here and hit this set button so I can put it where I want it to go. So I'm going to hit set. I'm going to get this dialog. This is your standard Carlson file dialog. If you like the Windows dialogs, you can hit this browse button right there, and that's going to put you in that very familiar Windows dialog. You've got to save as type, pull down here. You've got some other views. You can sort and do all kinds of things, navigate your way through it with their typical Windows type of thing. Okay. But right now we're going to talk about this one because there's some additional functionality in this that I really like. You may hate it. You may always use that browse button. That's perfectly fine. Okay, but I like this one because it does a number of things. It gives me a list of folders right here in my pull down, you see, and I've got from where I've been before. Okay, so I can switch that. This sort of a recent folders list. I've got with whatever folder I'm sitting in, it shows me over here on the right my subfolders that are in that folder. And the main window shows me the files that are in the folder I'm sitting in. And then I also get down here a list of recent files, regardless of which folder they came from. Okay, so you can see up here the files are changing in this name. So that would change to a different folder. But I'm going to go to, now that I'm in my Carlson projects, I'm going to go over here into my subfolders. I've already set this one up to my 2024-02-08 survey class. I'll double click in that. That changes to that. I have nothing sitting here in that file, but I have two subfolders. I've got data sets and I've got field to finish quick start guide. So I'm going to go to data sets and open that one up. And now I see a bunch of files here. Now, when you see these files, you're going to maybe see these that have this little period in front of the name, a period and an underscore. Those you may safely ignore. You can even delete them from the software. In fact, I'm just going to slip out here into my standard uh, Windows File Explorer. I'm going to go down there to Drive C, Carlson Projects, Survey Class, Data Sets, and I'm going to sort by type. And I'm going to see all of, well, actually, let me sort by name. There we go. And you see all those that say dot underscore. I'm going to take all of those, and there's quite a few of them actually. And they're sort of gray. Now you may not see them because that's a hidden file type, and I've got mine set to show me hidden files. But the reason I have them, I'm going to just delete them so they don't confuse us. Okay. But the reason they are there in my folder, now I've cleared them out and I don't see them, is because all of these things were created on a Macintosh that's running Windows. So when a Mac runs, it creates those, that's called a resource fork, that dot underscore in front of the file name. It's a hidden file, and it pairs up with every normal file, and it tells the Macintosh operating system how things work. So they're of no use to you. It won't be anything, and it looks like that they're empty files. So you can just throw them away. I'm sorry that they're still in the data set. I should have cleaned those out so that they're not there for you when you download, but in any case, that's what they are. You may safely ignore them. So now we're making a blank drawing here. Remember, we're still running our little wizard. And if I just type a name right here, now you look at this top stripe, it says drawing to create parentheses DWG. That's the extension it's going to use. Okay. So I don't even need to type the extension. It's just going to create one. So I'm in my data sets folder and I'm going to call this one class example one. Okay. And I'm going to say down here at the bottom, open, or I can just hit enter. And it then fills this out and you can see there it is, all the way, including the .dwg. It's in my 2024-0208 survey class data sets folder. I'm ready. Everything is good to go. And I'm going to say next. And so when I do that, it's going to go to the next step in the wizard. And at this point, a lot of folks will just say exit because they don't have anything ready to go. But what this allows you to do is to change the data path. Right now, you see it's pointing to the same folder that my drawing lives in. That's what we talked about, that drawing folder format back when we were talking about where these data files go, either project layout or drawing folder layout or fixed folder. And then it lets me assign a coordinate file to this work. Okay. And it's either going to be a new coordinate file or it's going to be an existing coordinate file. So I can keep adding to it. I can make any coordinate file I can open and run while I'm running this drawing file. They're not linked to being the same name. However, the wizard comes up and offers by default this CRD file of the same name, if that's what you want to do. Now, right now it would be an existing file. I would need to set it to new if I wanted to choose that. You don't even have to have a coordinate file associated with the drawing. It can be blank. It can be missing. But if you're going to use Carlson points, you will need that coordinate file. That goes hand in hand with that concept. Okay. So if we say a new coordinate file, and then it says, okay, well, where do you want to import your points from? Got a data collector. It can go right straight into the same command as if you pulled down the points menu and chose, import your points from a data collector or from a text file or from, and it says this current CRD file, which is really sort of bad terminology. That doesn't mean the one that you have currently open. That means an existing coordinate file. So if some other coordinate file, you can import points from another CRD file or a text file or from the data collector or no import, and it skips all that. All that this is doing is just doing these typical commands that you would normally do when you start up a new job. And that's what the wizard is there. That's its intent, is to make you step through those typical things and not have to go and find each of those commands and run them separately. Okay. So we're going to take that as it is, make sure it's a new coordinate file. One bit of warning here. If you say new on this coordinate file, and if you then say down here at the coordinate file, but you choose this set button, if you go here and find, let's say this is one, you see these are existing files. Okay, so if you find that there, but even though we've said new, it's going to then, let's see if it's going to be processing new file. Oh no, when I find it there, you see it switches it back to existing. But if you then said new and you keep this here, it will overwrite that file. Okay, so let's make sure we I'm going to change this back now to this one that we called, I just had the class example one, just like that. Right. So just be real careful with that business right there if you're going to use this on the coordinate files because, and it should warn you that it's getting ready to overwrite something so you don't do it accidentally, but pay attention on that because it will do what you tell it to do, okay? Then I'll go next and it will finish and it will dump me into my Carlson environment, okay? Now, a couple of things about layout. First of all, can everybody see everything okay? You can see these little buttons and stuff. Everybody, okay, Jason, give me a thumbs up. Good. All right. So, but let me know, like, if you're looking at something here, if we go through this and you can't really read that text, I can make those bigger if that would be helpful. But if you can see it okay, this, I can leave them like that. Okay, but all right. Um, so now we've got basically an empty drawing. We got things set up here. There's not much in it, but we did do something when we came in with that wizard and I switched to that Carlson software, National CAD Standards Survey drawing template. And here's what it did. Let's go to the view menu and look at our layer control menu. And this is our layers list. And you can see there's a whole bunch of pre-built layers with color and line styles, although the line styles looks pretty, well, there's one there. Centers have center lines. There's a stockade fence, although they misspelled it, stockade fence. Barbed wire chain link. So they've got a couple of different assignments. Uh, looks like the line weights are all set to default. So maybe, this, so you're going to have a set of layers that you typically use, or maybe a client defines where those, what those layers are going to be. But I've got a bunch of these that say start with G, which generally means general. And then I've got a bunch that say V. And the V, believe it or not, means survey. And the reason for that is like C would be civil. That would be like a design element, typically a proposed something or other. A dash would be architectural. V dash is survey because the S dash means structural. Like that's in the National CAD Standards layer naming convention. Okay. So the structural guys got in line first and they took the S instead of leaving it for us surveyors. So we're stuck with these. But anyway, you can see, and this can be as detailed and defined as you need it to be. And then you would, put this on text, is my current layer. But you would preset all of this stuff up and then save that into a drawing template and use that to start your new drawings from. Okay. A lot of times though, you're going to get a drawing from somebody else maybe that has already started it, and you're just going to have to take what they give you, and you can transfer those things from a drawing template into this drawing. I'll show you how to do that here in a little bit later on, through that same mechanism that we just saw with that view layer control. Okay, that's a very powerful command. We'll come back to that from time and time again. Okay. So now I'm going to do a couple of things. I'm going to go to my settings menu. I'm going to go to my Carlson menus and I'm going to make sure I'm running my survey modules. And I can tell that because the first menu that's available beyond that seventh menu called points So file, edit, view, draw, inquiry settings, and points. Those are common to every Carlson module. They all have those menus and they're all identical. And it's the menus that follow that tell you which module that you're in. So I'm in the survey module and those menus are survey, COGO, centerline, area layout, annotate, surface, GIS. I have express tools because, and that's nothing to do with Carlson. That's just a couple of sort of express tools from CAD. It gives you things like exploding text where you can take text and it will actually explode the arcs and straight lines that form the actual pieces of text, if you need to do stuff like that. So, a couple of additional functionalities in there. I'll leave that to your own discovery. All right. So we're going to be here in our survey system for these 2 days. We'll just leave it in that. So the next one I want to look at is real quick under settings. We're going to go to, let's just take the first one, this drawing setup. And when this comes up, you're going to see this, which is, see that 30 that we did? Now there's that 0.1 and 0.08, which was 3 and 2.4. And those were set up for me when I went through the wizard. Okay? And there's a couple of additional things in this one that the wizard didn't have. Things like which angle mode to use. It did have this coordinate system, but it didn't have all of these different conversion factors. If I had those known, I could use. But down here's my project name and number, location. And if I had a particular rotation, now this rotation is if you happen to be trying to line your coordinate system up with the particular rotation of a deed description. And let's say you've determined that your deeds are okay, they match things on the ground, but there's a 3 degrees, 15-minute, and 30-second rotation, that's not matching. This is not a common thing to do, but it lets you do that. The more common thing that we do nowadays, particularly with modern equipment, is we leave that rotation set to 0 and we're going to work in a projected coordinate system, such as one of the state plane zones. And then everything can line up. We can get aerial maps that we can get from other sources and everything's going to load up. We can look at GIS information or, GIS information. Things like Google Earth or Bing Maps, we can load into our software, okay? The other thing that you see here is this, right here, this LT scale is set to 30. Much like when I changed this scale up here, these values under drawing units and these numbers here recomputed. Anytime I change this number here, keep an eye over here on this LT scale as well. Let's say if I put that to 50 and hit enter, did you see how those changed now? That puts my LT scale to 50. Now, the reason I point this out, I'm going to put this back to 30 and my tab out of the field. The reason I point this out is because this really is changing. The older way of doing this, back when Carlson was first developing its software, is AutoCAD didn't have very much in the line of line types, or what they did have, it was very hard to use. And so Carlson had to make their own line styles for the surveyors, and they're pretty nice. But they are dependent on having the line type scale set to match the drawing scale. But the way we typically do it is we want to make sure that LT scale is always set to 1. So anytime I'm doing this, I always go to the settings menu, drawing setup. I look at that and I change it here to 1. Okay, and the reason for that is with this other system variable, and I'm going to come down here on my command line down at the bottom of my screen, and I'm going to type MSLT scale, and that says model space line type scale. And right now it's set to on, and that's because that is what's set in that drawing template. So sometimes you'll see that is set to off, but you want that to be on, and you want that LT scale, this, and this is the same number. You see right now it's set to 0.999, but I want that to be 1. Okay. So when you have that set to 1 and MSLT scale is on, then anytime you're using annotative scaling, and this has nothing to do with Carlson, this is all to do over here on this annotation scaling. So right now, Carlson is making it match. When I said I wanted to use my inch to 30, so it's setting it up to there, but I want to make sure that I've got my my two annotation visibility is on, and my automatic annotation on and off is also set to on. So those two switches down here are set, and they're going to follow annotation scaling, and that's going to do something. We're not going to have any time to really go over that very much in here, but if you use a text style that is defined to be annotative, then when you change your drawing scale, the text is going to redisplay itself at that large, a larger or smaller scale, so that it maintains that same paper size if you were to plot it at that new scale, if that makes sense. So if I do a piece of text and I use a style that is not annotative, which is by default what these things are set up to be, then that text is whatever it is at the time it was created, and it stays that way. But if it happens to be defined with a text style that is annotative, then it will change and redisplay its size based on this annotative scaling. Okay, it's a CAD concept. You don't have to use it, but it's a helpful tool if you do some things that get plotted at different scales for different purposes, like overview maps versus detail maps. It can help set those up. All right, so little more detailed CAD topic, we'll leave that for another day and for your own discovery. However, that's what it's for, and that's one of the reasons I always go to settings, drawing setup, and I make sure that this gets set to 1, because my wizard is always going to match it up to this number, and I want to reset it back to 1 so that my line styles show up the way I expect them to do. Otherwise, the line scaling gets sort of messed up. All right. So now, in the last bit we'll talk about here is on our settings menu again. And again, you see some of those things: set the drawing project folder. That was in our wizard. Look at the points menu real quick, where you could set the coordinate file. That was in our wizard. Okay. Let's go back to settings and look at Carlson configure. We get this little guy up, go through these real quick, but the general settings button, I just want to show you right up here in the upper left is where it says use the startup wizard. So if you have ever turned that off and you'd like to get it back on, that's where you can turn it back on. Okay. I'm going to cancel that and exit this for just a quick second, because we are at a good point to take our mid-morning break. So we're going to put a bookmark here. I will see if there's any questions so far. I know we've sort of gone from very basic stuff. We're going to whip through these settings, and then we're going to start getting into having some actual fun and learning some of this stuff when we come back. All right. Any questions anybody think of, or are we all good? Okay, everybody's good. So I'm going to pause the recording. My record. So we left off looking at some settings here. We're going to go through these really quickly. So I'm going to go to the settings menu and I'm going to choose Carlson configure. I'm going to get this little box up here. Now, most of this stuff is sort of set and forget. You set them up once and leave things alone and they'll go from there. So a couple of things that we might want to look at. First of all, since we're all surveyors here, this button in the lower right that says localization settings, do not confuse that with, say, a GPS localization. That has nothing to do with that. This localization is where you can set things up to work in, say, different languages, different type of defaults. And if you're, um, like right now, here's some annotation defaults, the line type text scalar. So these are just where you set up some default settings and values, and it allows you to localize it and you see you've got a save button. So you can make localizations for different areas if you have offices all over the country, all over the world, that kind of stuff. Okay, so nothing really that concerns us in the surveying sense. The first one that we're going to really see that's going to have some possible work for us is in this, let's see, not so much that, but the surface settings, the third button down on the right-hand half called surface settings. We look at that. The one thing that I want to make sure that you have on is, or two checkbox rather down here, is to have the track 10 history checked on, and then include detailed source data is checked on, and track the surface data changes. Those two are on, so you can, if you make edits to your 10 files, your triangulated irregular network files, then you can track those changes and roll them back if you need to, and that sort of thing. Not anything that if you, and I'm not a big proponent myself of going in and directly editing the resulting 10. I like to look at what's caused my 10 to have a problem in a particular area and fix the data that caused that problem in the first place, and then rebuild the 10 from scratch, from scratch. That's my approach. It's not necessarily everybody's. And so that's why we have these switches. So I would say turn those three things on as a minimum. You're good to go with that one. Okay. The next one is just to the left of that, the third one on the left called survey settings. And now I don't know what yours up here for the CG survey menu is set. The default used to be that it came in and that was set to compact. Is that what your all's is set to now, or is it set to none? Yours is set to compact, Jason, or to none?
Yeah, mine's at compact.
Okay. So what this is, I'll go ahead and turn that on and say, okay, and exit and show it to you. That is this little menu right here. Okay, that CG survey. You got all these file commands like coordinate files, new, open, close, raw files, check, traverse, coordinate geometry, draw, management topo tools, etc., or the full CG menu mode. Now, what that CG means is Cowherd and Goodman. It's the old C&G software. And Carlson bought that company, and a lot of surveyors across the country used that software when Carlson bought them and incorporated the program and functionality into the Carlson product. A lot of the surveyors were left thinking, oh my gosh, well, they pulled the rug out from under me. I was using that. I was used to those commands. Well, that's just a way to allow them to continue to run the C&G software as part of this new Carlson product. And when I say new, I'm talking about, 20 years ago new, back when they bought C&G. So that's sort of a carryover. And it's really of no use to you if you do not use the C&G survey system. If you do and you like to hold on to that, you can certainly use it. So what I like to do is in my settings, Carlson configure under survey settings, I like to change that from compact to none. So then when we come back out of it, you'll see that menu disappear and it won't take up space on my screen. Okay. All right. Now, the next thing down here is my initial traverse side shot angle mode. If you're always computing with angle right, you can set that up there and it's just the initial. You can always change away from it if you want. I like to have it prompt me because sometimes I'm doing computations, not necessarily, computing observations where I would typically have angle right. Sometimes I may want to have those just ask me which way I want to use it. So I have leave mine set to prompt. I can say to show the occupy and backside points on the status bar. And what that means is when you're doing any of these COGO commands like traversing, side shots, and all that, down here on the very bottom of the screen, down here at the where right on mine, you see the word ready. You would see an OC and then a point number, and you would see BS and a point number. So your occupied point, your backside, and it shows you what they are on the status bar. I'm not convinced that works all the time, especially with the IntelliCAD version. There's something about the graphics of it that doesn't always show up. And it's really not necessary because there's a quick little um, trick to reset to make sure you always know where you're going to be. And I'll show you that when we get to some of the COGO commands. You just basically run a real quick inverse from your backside point to the occupied point, and that's where you're now left in your setup. If you do an inverse from 0.5 to 0.7, and then you're getting ready to do some side shots or traversing or any of that kind of stuff, if you inverse from 5 to 7, at that point, you are now occupying 7 and you're backsliding 5 because you just came from 0.5 and went to 0.7, just as if you're traversing, okay? So that's a real quick way to reset that, even if you don't see where you are in your normal commands. Because sometimes you'll get a phone call or you'll get some kind of interruption and you forget where you are and you have to go back and reset, okay? Now, the rest of these automatic raw file and automatic lines on or off, or turn it on or not. That means when you run coordinate file computation, when you run coordinate geometry computations, COGO commands, if you turn this automatic raw file on, it's going to open up a raw file and capture those, much like an audit trail that you can then go back through and make edits to that list of commands if you want. You can also turn that on and off manually when you get ready to run those commands, which is the way I like to do it, so it's not just constantly generating these huge raw files and stuff for me. The automatic line on, lines are drawn when you're doing COGO commands. Lines are drawn when you traverse, when you go from a setup to a move ahead point, and then you do a bunch of side shots, blah, 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 and then you traverse up to your next occupied point. So it draws lines between backside and occupied into the drawing itself. And again, it's not really, my way of working. Some people like to see that happen. That's fine. Turn it on there if you want. Okay. Automatic point object snap on. I leave mine checked on because there is a real nice snapping mode for this point object snaps. And again, you can turn it on the fly. So I'll show you how that works when we start to look at some of the points as well. And then the next one is this automatic compare DWG points with the coordinate file when you start up. Now, this can be confusing, but it can also be helpful. And what it does is it looks at any Carlson points that you have in the drawing, and it compares those point locations to the points that are stored in the CRD file. And if they don't match, it gives you a message to that effect. So you might have gotten something out of sync and you have to go back and reset them. Okay. So again, just depends. If you're really good and strong with your point management, and you know, because I plenty of times I don't even use Carlson points at all. When I'm doing civil design work, if I'm doing road designs and such like that, I don't even use Carlson points. Okay? I'm not, but if I have some things like from a survey um, company, or if I actually have done the surveying myself out in the field and I bring those things in, I might want to see those points, then I certainly will have those and use them. But I've done entire projects, I mean, big multi-acre drainage studies and access designs and that sort of stuff without using the first Carlson points. So they're not required. So I generally don't have that checked on, but if you do and you're really good and adept at keeping track of which files you got open, you want to have that tracking on there for you just as a check, then turn it on there. The LDT Fieldbook codes is a way of linking this up with the old land desktop system. That was an Autodesk based product that a lot of surveyors used as well. We're not going to be using those right now. We're going to do our own field to finish with those kind of codes that we'll develop on our own. Okay. So really the biggest thing here is to set this menu. If you want to use it, use it. If not, turn it off and set your angle mode. These and then automatic point snapping I like to have on. I don't particularly care about this showing the occupied and backside on the status bar. It's on just by default. If it works, if it's helpful, that's fine. Okay. So we'll say okay to that. Now, the rest of these, I'm not going to get into all this project and data folders and startup and drawing, other than let's look at project data folders. And here's those three different ways I was telling you. By default, we're going to stick with drawing folder, but under this project folder is where you can define a particular set of folders. And you see, this is completely arbitrary and I have control over it here. And then when I do my setup and my data type subfolders, is I get a list of all of these different type of Carlson files. Like here are this .cl file is a centerline file, and I'm telling it I want it to go in project data, alignments, and profiles. Down here's one where I've got a DCF, which is a deed correlation file. It's going to go in project data, deed info, DES. Okay, lot descriptions, you're going to go in surveying points. So you get the idea. And you don't have to define all of these 236 different ones, but you can define only the ones that you use most often. And again, all you're doing is establishing a starting location to wherever these folders are for when the software asks you to open a file or save a file. You can navigate away from that at any point. That's all it's doing. It doesn't force anything anywhere. It's there. And you notice that if you do use this method, you can put things that have nothing to do with Carlson, like a PDF file or some contract information, deliverables, et cetera, different things that you can set up here based on the way you organize your own work. Okay. The other nice thing about this command is, and I'd leave mine at drawing folder, that's where I'm going to do my work. But the nice thing about this, let's say you're working and you encounter a file with a uh, with an extension on it that you don't know what it means. Okay, so as an example, let's look over here. This is their data sets, and I'm going to come down here and I see, oh, here's a file called let's see, there's a .lev file, level data. Well, that sort of tells you level data. Well, here's one that's a .his, mantopo.his. There's one called .fld. So maybe I don't know what those are, and I'd like to find out. Well, if I go into my settings, Carlson configure, and look at this project data folder and just temporarily put it on this project data folder and hit this data type subfolders, I'm going to get this list up here, and it's going to tell me when I can sort, by different categories here. I sort it up here by clicking on, and that was what was the one was an FLD. And if I come down here and find, there is FLD right there. I look over here and oh, that's a field to finish code table. What was the other one? Was an HIS, right? So I scroll down here and I find HIS, and of course it's not going to be there. That's a coordinate history file is what it is, but I guess it's not in our list. Probably because you're never prompted for that one. But you get the idea. Here's a .cut file. Well, that's a dragline sequence report. That's sets up the amount of cut for a mining operation. Okay. CRB, template curb definition. All right, so these different descriptions, when you see a particular, there was one up there called a .co. That was I look over here and I see that's a centerline file. So it's a nice little way to see if I don't recognize one of these data types, I can just run this, temporarily go to project folder and hit the data type subfolders, find the one I'm looking for, read the description over here as to what it is, and that'll maybe give you some further insights. Then I'm going to come back and just cancel that because I don't want to change it. All right, now the general settings and the one we want to make some use out of here. And I'm not going to spend a lot of time on this either, but again, that's turned the wizard back on. These other settings on the left, I'm going to say you can match mine, except for this one right here, use software rendering. Make sure yours is off so that you can take advantage of your 3D graphics card hardware on your computer. I have to use software rendering on mine because I'm running this on a non-Windows computer. It's a Macintosh, and I'm running it on Windows, which is actually running through an emulator. It's basically in my setup, Windows, and I'm running Windows 10 right now, but Windows is actually a little program that's running called Parallels, and it loads up the entire Windows operating system as a little separately running program on my Macintosh system. And so because of that, it isolates me away from my graphics card hardware. It doesn't let me write and read and write directly to that hardware. So that's why I have to use software rendering on mine. Everything else, though, you can match mine if you'd like. Make sure your software rendering is not checked. And then we're going to talk about right over here really quickly, this last little section on the right, these object linking. And you can see I've got all of mine on, and I'll explain what these do very quickly. When you link points with a CRD file. Now, it used to be this was more necessary in times past because it never gave you the warnings. So if you did not have that checked and you were doing some points, you read in some points from a coordinate file and you put them in your drawing, they're there, and you see them in your drawing. But then if you did not have that checked on, you could then move those points around in the drawing and they would no longer match the value that they have in the CRD file. And there would be no warning, okay, in the old days. Now it pops up and tells you, it warns you about it. So the switch is almost not even necessary anymore. But What that means is when that point was created in the drawing, either by reading it from a coordinate file or by some kind of computation, then if you move that point in the drawing, they no longer match. And you have to run a command under your points menu that says to update the drawing from the CRD file or update the CRD file from the drawing. So it will reset those to make them match. If the linking is on, then if you move the points in the drawing, it would automatically, and in the old days, without warning, also change the value of those numbers in the CRD file. So you can see why that used to be a problem, because a lot of folks using this software weren't even aware of this switch. And if they're all working, say you got multiple users working on the same project, working on the same file, had some, like in a surveying company, had a big company down in Charlotte, North Carolina that had, oh, I don't know, 15 or 20 people in their survey department. And I was telling them about this switch, and the guy goes, the manager says, oh my gosh, I want you guys to all get up from your computer. We're all in a conference room in the training room. Everybody get up and go back to your office right now. Check your computers and tell me what this says. So some of them came back and, I don't know, roughly half of them had the switch on and half didn't. And he said, well, that explains the last lawsuit we had. And I said, what do you mean? Well, some people work with the understanding that the CRD file, the outside coordinate file, is the authoritative source of that coordinate's position. So when they put the point in the drawing, and as they're working along, they know that they could go in there, and if the point is in the way of something else, they just grab it and move it with a CAD move and just move it out of the way, sometimes just very slightly, okay? Well, if the switch was set on to link it when that point was made in the drawing, then moving that updated the coordinate file, didn't tell them about it. Okay. If it is off, and that's the way some of these folks worked, because they knew it was not going to update the CRD file, so they would just willy-nilly move the points around. Well, then somebody else opens up the file and they have that switch normally on their computer, but when the point was created in the first place, it was off, and they're thinking it's on. And so they're not aware that they're in two different locations. All right. So it got things out of sync. And some people thought that they were out of sync by design. Some people weren't aware that they're out of sync. They caused all kinds of problems. And they were caused by just very slight movements, which changed where they computed, areas and property boundaries and that sort of stuff. You get a sense of how that happens, because a lot of times you wouldn't see the change graphically because it was so slight, but it would come up with, maybe the boundary descriptions were not exactly correct. Okay, and then they might go out and stake a point in the field and it would be incorrect. So it could be a real problem. Well, Carlson figured that out, that it was a real problem. And then several years back, 10 or 15 years ago, they put warnings in there. So now no matter what that switch is set to, it will tell you when they're out of sync. It will tell you that, hey, you've moved a point. Do you want to, they now differ. Which one do you want to use? And it will offer to let you update it. Okay. Now, the next line work with points means when you have line work that you've drawn with points, you've drawn because you have specified particular point numbers instead of just clicking spots on the screen, then if those points should move, it will automatically bring the line that went through that point. It will bring those right along with the move. Okay. Now it's a one-way link in the sense that when you move the point, the line moves with it. But if you move the line, if you just grip at that polyline, that does not move the point. We'll go through a real quick example of some of these. Linking labels with line work. If that's on and your line work has been annotated, that's what labels mean. They come from the annotation menu, the annotate menu. Then, or the area layout menu, any of those labels that were created from that data, and if the line work changes, those labels will change along with it. Okay, the link line work with center lines, and this has to do with when you're creating center lines from line work. This one is two-way, by the way. So if you create a center line file and it's linked to a line in the drawing, the line work, if you go in and edit the center line file and save those edits, the line work redraws itself to match. Likewise, if you change the line work, it will automatically go into the centerline file and change the definitions to match what you changed the graphics to be. Okay. And then grouping the point entities, that just lets you work with Carlson points as if they were a single thing, but they're really three different things. A Carlson point consists of a CAD point and two blocks. One block is the symbol, which is just a graphic block, and it can or cannot be there. It could be that you don't use a symbol, but it typically would be. And the other block is a block of attributes. The three attributes that it uses are the point number, the description, and the elevation. Okay, so those are those three different entities, and if you group them, they behave as a single entity when you move them around. And then you want to maintain your coordinate file history because, again, you can, let's say you've made a bunch of point file edits, you can roll that history back and reset if you need to. Okay, so it's a nice thing to have happen. All right. So that's all we need to talk about the settings. We'll say okay, and we'll exit that. And let's now do a real quick demonstration on that linking so you understand how they work. Let's type zoom at the command line, and it's going to bring this set of options up. I'm going to choose the letter C for center. It's my fourth option in my list. And I'm going to center that at 5,000, comma, 5,000. Okay. As much as I've been harping on state plane coordinates and all of that, that's my typical old surveying starting point, 5,000, 5,000, or 5,000, 10,000. Some people use to make sure they know that the northings and eastings are different. All right, now it wants to know a zoom factor or a view height. Now this view height is not the height above the ground. It's the height on the screen. It's the distance from the bottom of the screen to the top of the screen in ground units. So let's say if I wanted to just say 100 feet, I'm going to type 100. I'm going to hit enter. And so now when I move the cursor around, I'm going to be about in the middle of the screen somewhere there. And if you look down here at the bottom, right here at the bottom of my status bar, you see those coordinates. So I'm getting right in the middle, and that's roughly 5,000, 5,000. You see 49.97, some change, comma, 5,000, some change, comma, 0. So that's where that cursor is sitting right now. So that got centered there. Now the 100 is if I'm sitting down here at the bottom, now read it goes in X, Y, Z on my status bar. So that's at 49.51, so 49.50-ish. I go up here toward the top, and it's at 50.48, so 50.50-ish. So 49.50 to 50.50, that's my 100 feet-ish, right? 50 feet either way from 5,000, top to bottom. That was that height. So that's a standard old CAD command. It's nothing to do with Carlson at all. It just lets you position where you are in coordinate space in your drawing. That was the zoom command. Give it a center, type it in, give it a height, and it's the bottom to the top of the screen. So I know about what distances are going to be. All right. Now let's go to our points menu and let's look first at our point defaults. And we're going to set a couple of things here. I'm going to make sure I turn on my descriptions, my elevations, and locate on my real Z axis. And I'm going to look over here at the these little pictures that's going to show me some previews. One of which is the attribute layout ID right here in the middle. Mine is set to 2. If I change that to 1, that's the default. And that it's not exactly clear here, but the way this happens is when you put a point in, you're going to get the point number centered over the point, which is right in here in this indent spot. And the elevation will be to the right of it, and the description will be centered below the spot. So this is showing left justified here, but they're not really, they're centered. The point number and the description are centered above and below the point, and the elevation is off to the right. I like this one where everything is off to the right, and that one is left justified. And you can see these different options as to how they're going to work. It changes the order. Now the description is up and the elevation is below, or here's a case where the elevation is kicked up at a 45-degree angle. So if you're doing those for points and you freeze the point number and descriptions, the elevation is left, the little point symbol, you might see a lot of like a spot elevations on a topo map, you might see with the elevations kicked up at a 45-degree angle. You might see that sometimes. All right. So that just, and again, we're just setting defaults. And now I'm going to come down here to the symbol. There's a plus mark. If I choose this select symbol, I get to choose what I want my default points to look like. And you can see, I'm sure you've been through these before. But here's where it typically starts. It looks like this. So there's a number of different symbols that you can use, and it's up here in this category. Don't forget this category you can change. You can pull that down. You got points, you got trees, you've got inlets and manholes, you've got mapping symbols. You know, these are all just the symbol that gets drawn for the points. So I'm going to go back to points. And I'm going to choose, let's say this SPT10 would be an X, right? Now, I will use point numbers, which I wish they would change that to say point names because numbers can be alphanumeric. But anyway, that's just holdover from the old days. Point numbers I will use, and I'm going to automatically number my points. I'm going to start with let's start with point 1001. Right, you can start with 1, you can start whatever, you can give it a layer that these are going to go on. We'll just leave it at that. Use annotative points. This switch right here is if you use annotative points, then if you change the scale of the drawing, it's going to automatically resize the points to follow. But if you get into a lot of points, it takes a little bit of processing time. So I like to leave that turned off. And if I need to change those points, I'll rescale them manually. So I'm just going to leave that set the way it is. Drawing the point nodes, that means it's going to also draw the actual CAD point. I like to have that in there as part of that group. You can turn that on and off if you don't want to. And you can also, this masking the point attributes is it will put a little box behind the attributes, these point number, elevation, and descriptions, and it will block out whatever is underneath that in the drawing, just so you can't see it. It doesn't erase it, it just blocks it out. okay, if you want to mask them. And then there's this use field to finish for point styles that you may set your default up, and that would be fine. And so let's say you give it a description of FH for fire hydrant. If you've got a code that says FH uses a particular symbol and gun on a particular layer, it's going to override what you have said here and change it. I'm going to uncheck that for now. We'll get into that a little bit later when we talk about field to finish. And then the GIS file, again, we're not doing GIS data collection, but that's a separate file that tracks GIS data if you set it up as part of your uh, point data collection. You can have it ask for additional information as well. Okay. So that's all I need for now. I'm going to say, okay, I've set my defaults. Now we're going to set a couple of points in here. We're going to go to points, and here is our first and foremost command that we use is to draw locate points. And this does either of those. It draws points that are in the coordinate file, or we're going to locate points by telling it where it's going to go. So if I choose that, I get this box that looks a lot like what we just set. There's our symbol. Up the top, we have a chance to switch to a different coordinate file. We can turn on to use descriptions and elevations, etc., and point numbers. There's our starting point number. We can say if we have duplicates, what do you want to do? Erase and redraw, or allow duplicates, or only draw the new ones, etc., etc. Here's that symbol size scalar. Remember that word tells us to think plotted inches. And our text size scalar, again, plotted inches that we set up in our initial project setup. Layer, etc., etc. The buttons at the bottom now are going to be how you want to do it. You can enter and assign. So if I click that button, it's going to say, okay, how do you want to do this? You want to enter by a grid coordinate or by a latitude and longitude? All right, I'm going to use a grid. And it wants me to enter the north. I'm going to use that center point that we had. I'm going to say 5,000. And the east, which is X, my 5,000. And it wants to know an elevation. Notice if I type text or snap, it will let me pick something in the drawing. It will read the numbers. If it's text, set the elevation to that. If I snap to something that has elevation, it will assume that elevation. Or I can enter and it's got those little angle brackets around it, meaning that that's the default condition. And you see that little prompt beside that that says, okay, it's waiting for me to enter a number. Let's just type 100. So it's going to be an elevation 100. I hit enter there and it asked me one more time. Now, what's my point description? I'm going to just type, I'll type center. That's the center of my points. And boom, bada bing, there it is. And now it wants to know, again, because I'm enter and assign. Here's my next northing. Let's go to 5025. And let's keep this at 5,000 in the east. So it should just be 25 points straight up. Elevation, I'll make 101.5. And the description is going to be just, let's call it mag for a magnetic nail. Okay, so now I've got 2 points established by typing coordinates. When you're through typing coordinates, and we are through, just hit enter to finish the command. Okay. So now there's 1001, 1002. Let's repeat our command, draw locate points. And we're going to just keep the same values. Now you notice my starting point number, because it's automatically incrementing, is set to 103 or 1003. And I'm going to now choose to screen pick. So this time I'm going to come down here, pick a point to create. Well, I'm going to just pick a point here. And it's now read the coordinates from the screen. It needs an elevation. I'm going to say 99.75. And it needs a description. And notice MAG is in those angle brackets because that was the last one I used. And I'll just hit that again. That was a mag point again. Another point to create. I'll come up here, call that one. And the elevation now, because I just typed the last one, it keeps that same elevation. Well, maybe this one I'm going to just say 0. And I'm going to call this one TRAV-1. Okay. And then one final one over here I'm going to do. And again, elevation is 0. And now TRAV-1 would be the same thing, but this time I'll call this one TRAV. And I'm finished. I'm going to hit enter. Okay. So everybody got some points now on your screen. And you see what's going on. So if I select one of these points, the whole thing lights up. It's all grouped together. And I look over here in my properties and I see it's a group. It has 3 things. There are 2 blocks. That's the symbol. That's one block. The other block is that block of attributes. Or there's also a point, which is the underlying CAD point, or the node, some people call that. And that's what that property is. And then here's what the blocks are. There's various different things with it. Okay. It's got an elevation, a point number, elevation, description. Okay. So I can look at those in that fashion. But you can also, once it's in the drawing, if you just double click it, it's going to pop this up where you can go through those same values, change them. You can tell it how many decimal places to display. So if I said 2 for that and said, okay, notice it goes down here. No, it didn't affect these other ones. They're still at 3. Okay, but it did make a change there. Notice I have 2 descriptions. There's a drawing description and there's a coordinate file description. All right, so if I said in here, magnetic nail. All right, so there now is a drawing description of magnetic nail. But let's go to the points menu and list our points. And we'll just list them all. We'll say, okay. Couple of things that have happened here is notice there's my project survey class, my project location, Pittsburgh, my job number 1, 2, 3, 4, 5, 6. Remember, we put those in under our settings, job settings, or project setting, project setup, whatever the command was. That's where those came in. And that's all those things are used for, are just to go on reports. So let's look at our reports now. We look at that points number 1001, 2, 3, 4, and 5. There's those values. Notice point 1003 right here, 99.75, but it says MAG. It doesn't say magnetic nail. That's because that is the description that is in the coordinate file. So if I erase this one out of the drawing and say redraw it, it will come in and just say MAG. But the fact that I'm able to have these 2 different descriptions, that's going to be sort of hinting at this idea of field to finish, because we can set up the field to finish controls that says when you read this coordinate file description, when you draw the point in the drawing, use this other description in the drawing. So that lets us store points like FH and then write out in the drawing fire hydrant or HYD or something separate. Okay. You also have a little control in this edit box. This is non-surface. So if you have a command, if you have a point and you're tracking elevations on all these points, and let's say you have one that's a fire hydrant, but you shot the fire hydrant on the top nut of the fire hydrant, which is about, I don't know what, 2.5, 3 feet off the ground. Well, you don't want that point to be used when you're calculating the surface because it's going to give you a little spike on the ground surface right there. So you would say non-surface for those particular type points. Or if it's, say, a benchmark that sometimes you'll see a railroad spike driven in the base of a pole that's maybe 2 feet off the ground, then you don't want to use that as a surface point. Okay, same thing, maybe a benchmark that's a chiseled spot on the bridge above it. All kinds of different reasons why you might not want to use those. And if you simply set those to non-surface for the point, even if you select the point when you go to build the surface, it won't be used. Okay. The other tabs at the top tells it the different points. You can click the button and switch it to, let's say it's just switch it to this one. You can type a name, you can hit the set button and also choose from the list. Same as if you click the button. Any notes, any GIS, which requires that CRDB format for the coordinate file. You can attach an image. So if you're out there establishing control points and you generally take a picture with your phone, you can add, and it will attach it to that. And then of course, some settings. It really is how many decimal places to show in the editor. That was that double click thing when I did the editor. So I say, okay, and now I've changed the image or changed the symbol, and we have the two different designations. Okay. So anybody got any particular questions on any of that so far? We've just got a bunch of points done. Now we're going to talk about some linking. We're going to draw a point, and we're going to go to the draw menu, and we're going to draw a 2D polyline. And we're going to leave the elevation set as whatever it is, 0, or even set it based on the first point. Let's set that based on the first point, for instance. And let's then say, make sure these others are not checked. And let's uncheck the use current drawing properties. And let's select a layer to put this on. And we're going to put this on, let's put it on G and O title block. Okay. And you can set a particular color. Right now it is set to by layer, which is what we typically want it to be. And we're going to say, okay. All right, so now set elevation by first point. We'll say, okay. And this is now one of the options, and this is why I'm using the Carlson command to draw the polyline. Obviously, you can draw a polyline just using P-line or the standard AutoCAD or IntelliCAD command to draw a polyline. But the Carlson command gives you this one little nice extra. It says pick point or point numbers. And so I'm going to start with point 1003, 1003. Okay. And then I'm going to go to 1001, and then to 1002. And then from 1004, 1005. And then I can, just keep doing this. Okay. So now what do I have? I've got a line here, a polyline. I look up here in my properties, I see it is a polyline indeed. It is on that layer, G and O title block, and it is 2D because it does not say 3D polyline. I also see that the grips have those little half grips in the midpoint that tells me it's a 2D. And I see the elevation down here is set to 99.75 because it read the elevation of 0.1003. That was the first one. And the option was set to stay at that elevation. And it's a 2D, so it's a constant elevation. It's not always zero. In fact, this, I'm going to spin this up in 3D. I'm going to zoom out a little bit. I'm going to hold the shift key. I'm going to hold the mouse wheel pressed in and I'm going to push it up. So you look what's going on. The 2 points down there that are at zero, you see they're falling down. And this line is set at a constant elevation of 99.75. So it's going to match that point, but it's not going to match those 2 points. See, one's at 99, one's at 100, one's at 101.5. So you see that indeed did exactly what we thought. I'm going to come back here and go back to my top view. And now, as a contrast, I'm going to say, draw 3D polygon. And now you see, I didn't get a box that came up in my case because I turned it off the last time I ran the command. So I'm going to choose this O for options and get this up. I will say show options on startup next time. And now I'm going to say, let's put that on a layer here. Let's call that V. It doesn't really matter. It should be control dot. And we'll set the color. I don't know what that layer might be set to, but I'm going to make this a green line, regardless of what layer says. Okay, say okay. And I'm going to do the same thing. 1003. Except sorry, the wrong button with my little finger here. So 1003, 1001 to 104 to 1205. And then maybe I'll snap to that corner. And I'm snapping. Make sure you understand CAD snapping. I've got a running object snap for endpoint. So I'm going to do one more here, and then I'm just going to draw it off up here to this side. And now, because that was 3D, you see as I zoom this around, I'm going to roll it up here so you see it went from that elevation to that elevation to that elevation. And then it went to this elevation, but that was zero, remember? Same thing here to zero. And then it snapped onto the corner there and the corner there. And then when I snapped at an open space, it just snapped down to zero because that was my current elevation. Okay. But if I look at it in plan view, they look identical. So just be aware what might be happening because I have seen plenty of drawing files where you get a bunch of stuff like this in it because people weren't aware that they were putting things at zero and they didn't know what was causing the problem. Now, watch what happens. This is going to demonstrate the linking line work with points, as well as linking points with coordinate files. So if I take this 1004, traverse 1 point, I'm going to just edit its elevation. I'm going to say 1004. And instead of its elevation of being zero, I'm going to say that had an elevation of 105. I say, okay, it's changed. And let's now take this point here, well, let's leave this one now and I'm just going to select it, highlight it, and I'm going to grab that grip and I'm going to move it up to here. Now watch what happens. I'm going to update the coordinate file for the modified point. Yes, I do. and the line work went right along for the ride. Okay. Now, if I look at that, you see when I changed that elevation to 105, let me update that elevation. Let's see here. Wow. Because I'd have to redraw 1004. That put it there. Wow, that's a bit of a bug. All right, so changing that should have pulled this with it up to there. All right, so that's good to find out. Linking line work with points only links changes in horizontal. So if I moved that to there, yes. Wow. I am undoing down to there. All right, so that's set to 1005. If I move that to there, now that's moved. Oh, but it didn't. Well, that's unfortunate. That was 0 at one point. So if I change that now, if I move this, let's just say move, if we go from here to dot XY of here and then give it an elevation of 105. Yes. So it's brought those points along and that brought it. So the move had to actually bring it to a new location vertically, but editing the actual coordinate here did not do the linking. Okay, so the linking is only going to be affected now the by things that when you move these values or if you edit the coordinate file, say edit points, and we'll try this one this way instead of 105, let's call it 101. Save and exit. Now, okay, so when I edited the value at 101 to 101 with the editor, the spreadsheet editor, that pulled the line with it. But if I just did the edit with this pop-up editor, it did not. change. All right, so that's interesting to find that out. That's a bit of a bug. So if I say made that 103 and hit enter, now I spin it up. Well, no, of course, now it's going to. It's going to work now. Wonder if it's just because it was 0. I make that one 1. It says 1. So if I edit points 1005, there's 181. And 1004, 03, say, exit. Uh-oh. All right, then that grip. It must just be with these points that are at 0. This to the dot xy of itself, but then give it that as an elevation. Yes. Now it's 200.75. And now file. I set that down to 102. All right, so that's now 102. All right, well, that's something very interesting and good to find out. The point editor, when you change those elevations by double clicking, if they happen to be sitting at 0, it does not actually update the point location. But now this one probably will. If I change that 99.75 to, let's call it 98, that changed. That now you can see is at 98. I look down at the bottom of my screen down here at the coordinates when I hover over the grip. It's 98. So that does. So apparently, at least in the IntelliCAD version, when you change the elevation of a point that is sitting at 0, it will not apparently update that. You have to go through the full editor and make that change. Okay. So we'll just keep that in mind. But that's how the point linking works with line work. Now, if, however, you do this, you select this, and let's just bring this line in like this, maybe this one in over here. And so now you see what I've done is I've just changed that location. It kept its previous elevation, but it's no longer on those points. Okay. Now that will stay that way even after a regen. But because this line was drawn with this setting turned on to link line work with points, and you saw when I moved the points, the lines went with it. But now when I move the line, the points are not going with it. But if I do anything to the point file, if I double click, say 105, and I'm just going to make it very slightly different here. So I'll make just put a little 1 out there on the elevation. Right. And maybe I'll have to do it horizontally, just throw one there. All right, so if I do that slight movement, and then if I do, it's not even doing that. Go back to my points editor. This is yeah, see, if I go back into that point editor and work on the actual coordinate value, then it reclaims the line. The same thing would happen to one up here. In fact, if I move this one just slightly up, it will now go back to the step and it pulls the line back. So just be aware that if you grip edit this line work, it will not pull the points, but any changes to the points, even if you just edit the file very slightly, once that point value changes, it triggers that linking. It goes back and recreates that line. So just be aware of how that linking works. Now I'm going to select this 3D polyline and get rid of it. So I'm now back to this 2D. I'll even select it and I'm going to change its elevation down to 0. Now you can see, in fact, that's what it is. It's at 0. I've got some things there. And let's go to the annotate menu and let's choose auto annotate. All right. And if you see, well, we're going to just take the defaults as to what shows up here, but you should see like angle over distance, because I've got angle as row 1 above and distance as row 1 below. But if you have them both say above, they can change however you want to see them. Doesn't much matter. I just want to show the linking. So I'm going to say okay. And now I'm going to pick that line, and that has computed. Remember this point called center and this point called mag, we set 25 feet above to the north. So there that is, right? Now, if we were to change this point right here, and I'm going to move it up to here, watch what happens. Yes, I'll update. And the labels, that's linked labels with line work, recomputed and followed the line as it goes. Now, a label is something that comes out of this annotation. And those are things like here I can annotate distance and bearing, all the, azimuth, different things. So it's not just an arbitrary piece of text, although that's all it is when I look at it in its properties. So if I select that and I look over here in my properties, I see that it's just a piece of M text because my default said to use M text. So it's not anything in particularly special about it, but because it was created with the annotate command by picking on that line and the line changed, it changed with it. And now this linking is 2D, I mean, two-way. So unlike the points linking, if I just do a grip edit, the labels still follow it, even though you notice I've changed this line away from that point. But now if I go back to that point, the northing was at 50, 25, and the easting was at 5,000. Put it back to where it was. We'll say okay. And now that pulls the line back and it pulls the labels back with it because the labels are always following that line. Okay. So that's how that linking works. And we'll do one last one here. Let's just go off to the side and we're going to draw a 2D polyline. We'll draw a 2D polyline and we're going to put this on a layer called, I think we're looking for there's V dash road dash C and T on. Okay. Color will be by layer. Everything's by layer. We'll say okay. I'm just going to come down here. I'm going to click a point here, a point here, point here, and a point here. Okay. I now have nothing in the world but a 2D polyline. I'm next going to go to my centerline menu and I'm going to say polyline to centerline file. And I'm going to call this one just test. It's in my datasets folder. Test, save. And now it says select the polyline that represents the center line. It also tells me that it should have been drawn in the direction of increasing stations. So I'm going to pick that. That reads the direction. It gives me the option on the command line to reverse it if I need. I don't need. I'm just going to say enter for my default beginning station of 0 plus 0, 0. It reads a bunch of stuff, tells me the numbers, says press enter to continue. I do that. I now have, if I look at my centerline editor, there's my file, and you see the little picture of it, and I open it up, and there's my little file, and I've got this, say, double clicking that reads off these values, the length, the station, whether it's tangential to the previous element, all those different kinds of things, all right? So there's that. Now I also have that same double click option that I did with the points. Is if I double click, it automatically puts me in the centerline editor because it knows it was turned into a center line. Okay. If it were just this one up here, say this white one, it's also just a polyline. But if I double click it, once my system comes back, escape all that. So if I double click that white one up there, notice it doesn't put me in the centerline editor. It puts me down here on the bottom into the p-edit command. Okay. So there's a little bit of a difference. Once you run the command and tell it, it's now associated with that, but it's no different properties wise. See, it is a polyline and this is a polyline. They're exactly the same. They have the same value. The one difference, the reason you can double click edit certain things like center lines, profiles, points, is that Carlson adds what are called these extended data. See this extended entity data and what are called reactors. Those are things that will react to certain things like a double click edit. So if I were to remove those two things from this red polyline now, it would no longer be associated with the centerline file. Okay, but here's what I'm talking about, the centerline linking. If I change this file, I'm going to actually come over here to the right-hand side, and I'm going to do a fillet. I'm just do a CAD fillet. I'm going to give it a radius of, let's say 20 feet. And I'm going to pick this and this. And so now what it did was create a curve in there with a radius of 20 feet. Now, double click that line again, and it brings up the test.cl. You see in the top stripe there, there's my centerline file. But notice it recognized the fact that you have now put a curve in there. And watch this part. If I go to this line here, my starting line, and I'm going to fit a curve, and I'm going to put a curve in there of, say, 50 feet. And say, okay. So that would now look like that. And if I say save and exit, watch the drawing in the screen. You see how it updates that automatically? And if I simply do a grip edit, it will take the file. So now I've got this out here, my line, my curve. If I double click my curve, make sure I say tangential to the previous element. Notice I've lost that tangency at that point. If I say okay, save and exit, it resets that to be tangent to that index. Okay. So that's how linking works. A number of different things to keep in mind and to be aware of as you work through some of your drawing stuff. All right, so at this point, any questions? Everybody good with what we have so far?
We're good.
All
I'm
right.
good.
All right. So now let's just erase everything in our drawing. So if we say edit, erase, and let's just say select, and let's just type the word ALL, hit enter, everything's gone. But of course, I still have my points out in my coordinate file. There they are. And we'll draw locate points, and we'll just hit draw all. And there they are. Notice 103 no longer says magnetic nail. Okay, it's back to being what the CRD file had. So I've got some points here. And let's go next to the points menu, and let's set the coordinate file. And this time, let's choose the exercise 1 coordinates as our coordinate file. So now we've set that. So now go to your points menu and list your points. Just list them all. And it's got point 1 through 22. Well, what happened to 1001 to 1005? And this is why I bring this up. And notice these points here are just, obviously they're not in the same space. They're not at 5,000, 5,000. They're just sort of arbitrary. Okay? So what has happened is that I've got points in my drawing that are not in my coordinate file. And I've got points in my coordinate file that are not in my drawing. So I can do a couple of things. I can draw locate points and just tell it to draw all, and it'll put those 22 points down where they are and leave these out here where they are. Or I could also just go to the points menu. I could come down here to point utilities and to this update over here, or I can start up here at this little Swiss Army knife in the top called coordinate file utilities. And I'm now looking at exercise 1 coordinates. And down here on the left-hand side, no, things on the left, These are things that work on the coordinate file as a whole, whereas things on the right tend to work on groups of points within that coordinate file. Okay. So I'm going to come down here on the left and I'm going to update the coordinate file from the drawing. And it says, all right, I can limit it to any particular descriptions. Right now it says star, that an asterisk, that means take everything. All right. Any particular custom attributes, I don't have any. They're what they're supposed to be. I'm going to say okay. And it now says, okay, select entities. I read the line above to see what kind of entities it's looking for. It's looking for Carlson or Land Development Desktop or Softdesk or Inroads or Eagle Point or Geoda Meter or Leica or Microsurvey points. Well, I have Carlson points and I can just drag my window around them, hit enter, and boom. My command is done. If I list my points, same command now as we had before, I see 1 through 22, and I also see 1001 through 1005. Okay. Now, I can also update the drawing from the coordinate file. Now, this will do the very same thing as if I just did a draw locate points. But I want to do this. Now, this also lets you, right now, we're doing it from a case of where we had points in the drawing. We did not have them in the coordinate file. There was no overlap. There were no points of the same number with different locations. But these commands will help you resolve even those particular situations. So if you said update the drawing from the coordinate file, if our coordinate file had different values for these same point numbers, it's going to now change these points in the drawing to match what's in my coordinate file. But so I'm going to say, I got some different options. Erase points from the drawing that are not in the coordinate file. That's another thing I could have done, and it would have gotten rid of these if I had not added those to the coordinate file. Or I can draw points from the coordinate file that are not in the drawing. That's what I'm going to do. I'm going to select a symbol, and let's use, we'll use this SPT4 this time. Numbers, descriptions, elevations, locate on the real Z, and I give them the layer name. We'll say okay. And boom, it says, okay, I drew 27 points. Now exit that. Now, what do I have here? I have this point, this circle point. I've got this X point. And you know why? Because if I select that, look what I have up here. I now have 6 entities and not just 2. Because I have a duplicate of that. I've got one. That's the one I just drew from the circle symbol. There's one with the X symbol. Okay, so it's duplicated one right on top of the other. Okay, so that's something that can happen. And if I also do zoom extents, I can see that I've got those points way up there, and I've also got these points way down here. Okay, so those are those points. Now there just happen to be a single point. There's point number 1 with all that information in it. Okay. Points up here. Now, this is going to get into, I see right now I've got, say, point 21 to 22. I'm going to come back to this area here, and I'm going to draw a polygon, just like this, okay? And I'm going to even get rid of those doubled points, and I'll draw them again. Let's just say draw. Make sure I've only got the one. Yeah, there's three there, so that's the one. All right, so I've got, let's say 22, 21. All right. Here's the command, and this is going to be sort of some of the things that you will be finding yourself getting into when you start to resolve deed points and computed points. I got a bunch of points down here around 0. I've got some up here around 5,000, 5,000. So maybe these are points I found in the field, and down here are points that I computed from deeds. So if I do a command, now there's another command that we'll see when we get into our deed processing tools that's a lot more sophisticated, but this is what's basically happening. And as I can go to my edit menu, and I'm going to align, and I'm going to do a 2D align. Okay, so it's going to ignore the elevations. It's going to keep the elevations where they are. But so now it says, well, what entities do you want to align? Well, I'm going to align these guys. I just selected a window around that. I've got 66, which means I had 22 times 3, 66. I'll hit enter. And now it says, pick a point or a point number. Well, read above, the line above that says the first source point. Well, that was, in this particular case, I'm going to say it was point number 22. So I'm going to say 22. And now it wants to know the first destination point. Well, that's going to be up here. I'm going to snap to that endpoint. Okay. And now it wants a second source point. In that case, it's going to be 21. And that one's going to be up here. Okay. And now it says, do you want to scale these objects based on those alignment points, yes or no? In which case I'm going to say, no, I need my distances to stay the same as I had them, but I do want to make this rotation and translation work, just no scaling. So I'm going to say no to my scale. And do you want to update the coordinates for point number? I'm going to say yes to all. And boom, there comes all of those points. So that was at points 1 through 22, but see how they are now rotated? These used to be rotated as a group to where these text elements were read horizontally on the screen. But because I aligned 22 to that endpoint, 21 to that endpoint, I did not scale it. It picked them all up, brought them here, rotated them as a group to match. And so that's sort of how we're going to see some of our deed processing tools work in a similar fashion. And that's going to be through things like your deed correlation. And if I look at that, and let's just give it sample. You see this column here, this is survey point and deed point. That lets us define a bunch of points that we found on the ground, a bunch of points we computed from deeds, and then, excuse me, we tell it the ones that we suspect go together. And it's going to then do a bunch of analysis and tell us, what's our best move and rotation to give us the best fit with the least amount of change. So it helps us to do what essentially we just did here, is as if we knew these points in that line. It's going to figure that stuff out for us. So we'll see those when we get to them. Now, if you don't like these things being rotated up here, you can do, all kinds of different things. The quickest, like here's one, you can twist the point attributes and set that to retwist them so that they can work. Let's just say twist by twist screen, and we'll say all with these symbols and the attributes relative to the screen. We're going to select them from the screen And let's just take these. And you see how they're now turned back horizontal the way they were. These others were left. But another real simple and easy way to do that is simply redraw the points, right? So if you draw locate the points and we say we're going to erase and redraw, draw all, there they are. And now everything is drawn, rotated into position. And here's where those people in that company down in Charlotte would do things like, well, that point's over top of that point. I'm just going to grab this and drag it out of the way. And so that now you'll get a warning. Let's say they wanted to move that out of the way. See, that happens there. And I'm going to say no. And I'm going to undo that to put it right back where it was. Okay. So a couple of ways you can handle whether these right over top of each other is you can select these. And if you grab the grip that's over the point, that's going to move the point itself. But if you grab the individual little label here, or what's called the attribute, you can rearrange those attributes like that individually. Another one is to go to the points and move point attributes. You pick the particular attribute you want to move and then set the rotation. Okay, so that's another way. The one that I use quite often is this move point attributes with a lever. So if I move this to be, say, over here, or maybe I moved that one to be over there. And one of the options is if you don't, if you want to reset that, just notice down here at the options on this command is to restore. So if you restore, it's going to put them back as if you had done a fresh draw locate points. Okay. So we've got a good sense of some of those ways of handling points. And again, on the point numbers, if we select this guy, get rid of him now. We'll go back to draw locate. Hey, let's just do a 2D polyline. We'll use the current. We'll stay at elevation 0, say okay. And if I pick a point, let's just say, I was up here, bink, bink, bink. And then I said 1 to 5. All right, so it went, I did bink, 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 and then it went from point number 1 to 2 to 3 to 4 to 5. And then I'm going to go from, let's say 10, I'll go backwards, 10 to 7. So 10-7. So it went 10 to 9 to 8 to 7. And if I go to my point object snapping, oh, that's not open correctly. Huh. All right. So if I hit enter there, and if I then my point object snap is off. If I go to settings, point object snap is now on. That's what I want it to be. Okay. So now if I draw a 2D polyline, and I'm going to type C to continue, and I'll continue this guy, and I'm going to just hover. Wow, that's not working. Point snap. Oh, it is not working with this, but no. Input midpoint extension, that's fine. Point object snap. Now this is where continue that. There we go. That's what I was trying to get to show. Is if I'm see one of the things is if I point to this point like this, if I try to point to that point, uh if I've got a symbol, it can snap to say the endpoint of that symbol, which is slightly off from that point. But if I'm using the point snapping, notice I'm pointing to the actual text attribute. But when you get that little pop-up, it tells me that's point number 6. It gives me the northing, easting elevation and tells me the coordinate file it's from. I click there. And now I'm going to jump over to here and just going to go 11 to 12. I'll come down here to 24 to 17 or 14 to 17 and enter there. Now that's just as if I had typed in that point number 12 and typed in point number 11. Back to fine. See that? You see it comes right to it because that was that point object snap. It's on my settings menu. It's right here. And that means that whatever you point to, if you point to part of the symbol, you can, with these snap modes, like endpoint and midpoint or center, if you have them on, that will grab those. So you want to point to the attributes so it grabs to the actual point itself. And that's a Carlson snap, not a CAD snap. This is going to always read that. Now, the reason mine wasn't reading earlier was because I think if you have this node snap set on, it interferes with that. So I think that was what was going on with mine. All right. So that should give you an idea of a couple of things you can do with points, with the Carlson draw commands that are going to ask for points or point numbers, and the fact that you can give ranges, you can give just a sequence of point numbers, you can snap using the point object snapping. And so it's just a really handy way for us as surveyors because we're so used to dealing with points that we can work with those and we don't have to go in and snap on nodes. We don't have to uh, try to figure much out other than if we know point, 5 through 12 should be connected, we can just type 5-12 and off we go. Okay. So with that, we're about 10 minutes over into our lunch break. You're going to get your whole hour, don't worry. So we're going to come back at 10 after. First of all, I'll ask, are there any questions to this point?
Not
Down
so
here.
far.
Everybody good? Okay.
Yep.
All right, so I'm going to pause the recording. So as we're looking in the manual on page 15, under point groups, I don't want to necessarily spend a whole lot of time on this, but this shows you how to go about making groups. And then shows a little an example here of using groups to then plot these corner points around the boundary of this subdivision plat of all of the interior lot corners um, is the example that's done for that. So if you all are all comfortable with using groups, we can leave that for your own uh, exercise on your own and just sort of, not waste the time to try to go through it. Everybody okay with that aspect of it if you're using groups, or do you want to see some of it? I'll be glad to step you through it if you want to see it. Everybody, yeah, everybody good to push ahead without going it, or anybody want to see it?
We're good.
Okay. Jason, you're good with that idea? Okay. So let's go then to where the next little bit that's in your book here, and we're not going to uh, necessarily go through that. We're going to do a little bit when we get to it for the surface modeling. Let me ask this. In terms of doing terrain modeling and surface modeling, um, does everybody understand the concept of break lines, why they are necessary, and how to form them? Everybody good with that, or uh, need some foundation in that? Again, I'd be glad to do it. I just don't want to go over ground that everybody's comfortable with if you're already good with it. Anybody need to go through a quick example on surface modeling? Or is everybody good with it? Jason, you're good with it, looks like. Okay, what about what about you folks, Craig and Cameron, or do you need to go over the surface modeling stuff, or do you guys do that a lot and you're comfortable with it? What's
No,
the
we're good.
you're good? Okay.
Yeah.
All righty. So let's push ahead then out of this and start talking about some of these some field to finish kind of concepts and how we can use that. So um, first thing is I'm going to go straight into this. Let's go straight into the survey exercises as well. So first of all, in terms of field to finish, how many or are you folks using that, or is that part of what you want to learn a little bit more about? Um,
That's something we need to learn about. We haven't used much of it yet.
okay, good. So we'll go over but 'cause like I said, I think that probably gives you the greatest leverage into um, some automation efficiencies than any other tool that I've seen in the software. So we'll take a look at that. And I want to let's go uh let's look first at some raw let me ask you this next. Do do either of you folks, the Brooks people and you at Cape Fear, Jason, are you using raw file processing to do adjustments on your survey measurements, or is the bulk of what you're using coming from, say, GPS stuff, and you're getting the adjustment straight out of like the broadcast corrections? Um,
Yeah, we're mainly using the GPS corrections.
okay. What about you folks, Craig and Cameron?
But I wouldn't mind going over the processing of the raw data.
Okay. All right. Yeah. Well, we'll take a look at that. I don't want to necessarily, because we could spend a week learning all this stuff on ServNet processing, which is the least squares processing stuff. So I'm not going to get so deeply into the weeds there that we miss out on the rest of the stuff, but I will show you how the raw file stuff works and how we can edit that and use it to our advantage. Because it's more, raw file processing is more than just adjusting the coordinates. It can also track certain things with this. So let's go to that part. And this will be on page 59 in the book. And we're going to choose this. There's a little discussion over here about adjusting your measurements, which doesn't necessarily apply so much, particularly if everything that you're getting is coming out of GPS observations. I mean, you can still do some network readjustment to make sure everything fits together in multiply redundant tied networks. That gets, into some pretty higher end thinking, but the biggest part of the adjustments was really intended for traversing types of observations. Um, so, you can read this little discussion about that on your own and about why we do it, but we typically are going to adjust our observations because there's always some amount of error. And if we have error that came about systematically, meaning it's a little bit here and a little bit there spread throughout the entire amount of observations, generally, um, as an even distribution through that. In other words, we didn't make a particular blunder at any one given observation. We just assume it's sort of spread out evenly across all of the different observations. And that's what some of these adjustment methods are going to talk about. So the first thing we'll do is we're going to start the exercise here on page 60, and we'll see about these traverse raw files work and what we can do with that as well. So we're going to start a new drawing of your choice. We're going to use a new coordinate file to use with it. And then we're going to open this raw file called raw file 1. And here's the process. So I'm in that same class example 1. That's fine if I want to do that. I'm going to go to my points menu. I'll erase points. And I'm going to say by number. And I'm just going to type all. And yes, take them from my coordinate file. Everything's out of my drawing. Everything's out of my coordinate file. I list my points just to verify, hit the all button, say okay. I see I've got 0 points. So now I've got an empty point file. I've erased everything in the drawing, even though I'm still in that same original starting drawing. So I'm just in a sort of, my starting area. I'm going to zoom center. back to 5,000, 5,000. We're going to do that 100-foot zoom height. So I'm sort of back centered where I'm supposed to be. Now, next thing then is I'm going to open that raw file called choose survey data processor. Choose new. So let's do that. Let's go to the survey menu and choose edit process raw data. Now this is going to come up into this raw file editor. Okay, now raw files have a extension of RW5, and that's because that is the same format file that came out of the old TDS, or the tripod data systems file. And that was such a popularly used field raw file format that Carlson just continued to use that as well. And a lot of other competing systems also use that same thing. But if we look on our little file menu on this inside editor under import, you can see all of these different things that it does support. So if you have files from somebody else, or if you have if you switch to a different field solution, at some point you can bring all of those raw files directly in to this as well. Okay, so we're going to make a new raw file. Right now you see up at the top here, it says RW5 none. So we're going to set it to a new raw file. And then do a save raw as, and we'll just call it test raw file. And so now you see it says test raw file. That's my RW5. My CRD file, coordinate file, is class example 1, and my control file is none. I do not have a control file being used with this. Now at this point, I'm just in an editor, and I can start putting in commands and putting in entries. So we're going to add a point, and we're going to put in that point to be 5,000, 5,000, elevation 100, control 1. So this will be just as if I had put a point in the drawing file. And so we're going to pull this down, and notice there's a bunch of codes here that I can choose. There's traverse, there's side shot, there's a height of an instrument, there's a backslight record, and there's a point storage. That's the one I want. Now you can do that a number of ways. You can do it with that pull down, or you can go to the add menu and choose from this. Okay, that's another way of getting to that same idea. And all of these little icons that you see here are going to correspond to commands that are also available in our little menu here as well. Okay, so we're ready to create our first point, and we're going to call that point number 1, and we're going to give it a value of 5,000, 5,000, elevation of 100, and a description of control 1. So now there it is. We've got a point in there, and it just keeps on going and letting us until we change our different input type. Now, while we're here, let's take a quick look at the file menu and look at the open and save settings. Okay, this is just when you first run this or command to edit process raw file, it's going to ask you to prompt for a raw file on startup. So when you first start it, does it ask you to open a raw file, or do you do it the way I had it, where it was not prompted and I had to go and set it? And then you can also have it automatically save the coordinate file, because this will compute coordinates and it can automatically save to it, or I'm going to leave it unchecked so it prompts me to if I want to after the fact. Okay, so I'll leave those unchecked, but I'm also going to set things that I want to look for as a description on my points. If I see those descriptions, it will tell the raw file processor that that's going to be a closing shot and that's going to be a shot for angle balance. Okay, again, for traversing type of things. Not really all that important for us right now, but that's just some of the settings. Now, what we have in the interface here, I've got, as you can see, as I start to add records, I've got a spreadsheet looking thing at the top, and I've got down below a graphics screen. Now, if you don't see your graphics screen, then it's probably because it is turned off. It might look like this. Okay. And notice I did that with this little icon, the pencil and the line work. It says graphics on and off. That turns it on and off. I can also do that from the display menu, graphics on. Okay. Several things. I'm going to show description records, show record headers, and show side shot records. What those are, these are show and hides, and those are things that the description records might simply be remarks. And that's what, like if I change this to be a description, then that's just a note that just lets me put something into this raw file as a note to self kind of thing. All right. And you can see in here, there's, just a little point number, northing and easting elevation. That would be like a description that says that's going to be my format. Okay. You can erase that and just type whatever you want. All right. So I'm going to actually, we're going to come back and change that to something else. But a couple of other settings that you can do as well is that you can so set your angles to degrees, minutes, and seconds, and their input as the degree part with a decimal, and then 2 minutes and 2 seconds. And any further second digits would be decimal portions of seconds. The vertical angle, whether you want to use a vertical angle or a zenith angle as a choice. Again, distances, whether it's slope distances or you're just computing horizontals, you're not carrying elevations. Graphics on and off, where we show the side shots or not. We do zoom mode. So these are all going to make sense once we start getting some data in here, we'll see it. But now look at our spreadsheet colors. If we look at these color settings, this is going to be something that if you start to use raw file processing in some depth, you're going to start to get used to what these mean. Right now, mine are set to be, and I don't recall if I've changed anything. These might be the defaults, I'm not sure. But if I have a traverse measurement, it's going to show up as red. If I have a side shot, it would be green. Set collection, you can see all that. I'm not going to read them to you. But notice the point is black. So that's this color right here. If you see line number 2, it's black text. Okay. Headers are blue. That's the point number, northing, easting, elevation, description. And then for the change down here, there's another one for my description that's called note. So those are the headers. They're now blue. And then you can see the note itself is this sort of gold color. And you can see that one up there as well. So all of these are going to indicate what they are, as well as this little designator in the pull downs beside it as well. Okay. So that's going to help a little bit with what we're doing. The other choices that we can look at is the spreadsheet settings. I guess that's makes them a little bit larger if you want to. It's not much there, huh? Just use a large font or not. I think I will. And the reason I will is because, well, I'm in my 60s, so you can figure that part out from there. All right. All right. So now the rest of these, and as you hover the mouse over these, you can see what they might bring up, some different things I can have done. But we've got your typical edit things, delete rows, modify measurements. Those are things you can just kind of click around and do yourself directly. We've got some display things. The add, that's where most of our entries are going to go. You can even add a coordinate geometry command, which we don't have it. We've only got the 1 point stored right now. But as we do this, and as we work through this, it's going to start to record these commands. Now we're right now in the editor, so we're just putting in the commands manually as we go. And then once that's all done, maybe if we have a completed traverse, we can then go to these process settings, okay? In fact, on our process settings on the process menu, you've got all kinds of different controls here, like the tolerance values for distances to whether it triggers, something for you to check on. If you are running a traverse and you're using checkpoints in your description, you might put like, here's my traverse point number 17. And I might, in my description, I would say 17 equals 3, because I'm checking back in onto point number 3, even though I'm computing point number 17. So it knows to treat that as a checkpoint, and it will compare those coordinates for you, okay? Then whether you turn your measurements to control points you want to store in the current file, you can see all of those on your own. There's no need to read all those for you, okay? And then these are all the ways that we can then choose these different particular adjustment processes. We have a series of tools as well. We can get reports on our direct reverse readings. We can reduce those direct reverse readings. These are the things we used to do, by hand in our field books. We would sort of come up with those averages. And now you can update a raw file from points. So let's say if I enter a bunch of point records here, point 1 I put in is 5,000, 5,000. If I got a coordinate file though that comes in and says point 1 should be, 386,422.5612, easting and my northing is 3,262,000. You get the idea. So I can start off this raw file with a bunch of point records storing with assumed coordinates. And then if I've got a real coordinate, I can then run that command, update raw from points, and it will update these starting values. And then I just simply reprocess this raw file, and it will change all of the resulting coordinates to the new ground-based coordinates instead of the assumed coordinates that I started with. But notice here too is a command to find a bad angle. Now there's another one that they could have put in here, and I'm surprised that I don't see it, that you can find a bad distance. And that is if you have a bad angle in your traverse, what that means is when it closes the figure, and I'll show you all this with some pictures here in a minute, it'll make a little more sense. When it should close to a known location and you're going to miss it by a little bit. So you're going to look at that misclosure vector. You're going to look at its distance and you're going to look at its direction. If the error was predominantly at one particular setup, so I've got one bad angle, then the misclosure line is going to be perpendicular to the line that bisects that angle. Okay, now again, I'll show you that graphically when we come to it. And the other option that is not one of the tools but should be is if a particular blunder were made in the distance measurement of that traverse, then the error of misclosure is going to be parallel to the leg that has the missing distance or the blown or blundered distance. Now, as you can tell, because we're using newer technology, GPS, and we're using, even if we're using total stations, all of that stuff is electronically captured. So those things don't happen very often anymore, but they're just mathematical tricks that we can look at the shapes of these things and come up with finding where a bad angle may be or a bad distance may be. And sometimes, like in the old days, we had to type these in and we might have transposed a digit or something like that as we're putting values into our spreadsheet. And those are tools to help us find them. Okay. Not bad tools, but they're pretty common sense once you see how they work. All right. So let's go to the next little step here, and we're going to put in that 5,000, 5,000, and we're going to establish a backsite here. If we had another point, we could use new coordinates, or we could just say start with a particular record or a particular direction. So we're going to use a backsite that has an azimuth value of 270 degrees or due west here. So we'll add this backsite record. Well, occupy point will be 1. We're not going to have a backsite point, but we'll set the azimuth in the set azimuth field. And then typically you would, and the set azimuth field would be 0, but the azimuth will be 270. And the set azimuth, that's where we would 0 the plate on our instrument. Okay. So instead of this description, I'm going to come all the way back here. I'm going to choose this backsite. All right. So now my occupied point, I'm going to change that to point number 1. My backsite point, I'm going to skip. So I don't have a point. Let's say I have an azimuth of 270 degrees. And now here's my, what used to be called set azimuth. They now change that to back circle. That makes a little bit of better sense. So I'm going to set that to 0. So in other words, I'm going to point to something that is at an azimuth of 270 degrees, but I'm going to set my circle to 0. So if I'm looking to the west, any angle I turn from that line will be an angle right from that 0 degree plate. And I'm just going to call that, maybe that's a church spire as to that azimuth location. Okay. So now I've got my backsite record, my backsite point. Let's just put in a dummy point of 99, which won't do anything. It's not going to make a difference for us here anyway. I think I go past that. It's not letting me go. beyond it. All right, so I'm just going to go down to my next record. I've now established a backslide. We don't see anything yet, but that's going to be here. So I'm going to go there and I'm going to now do a traverse point based on starting at point 1, looking at this 270-degree back azimuth, setting it 0, and we're going to turn 180 and go 100 feet to point 2, and then we're going to keep doing that all the way around to where it's going to close. So I'm going to say now this will be a traverse point. So now my occupied is point 1. And now I'm going to say point 2, and that's going to be an angle right of 180. Goes 100 degrees or 100 feet with a zenith angle of 90 degrees. And that's going to be control 2. Okay. Now, we're not looking
Hey,
at,
Ken,
yes, sir.
if I'm trying to, it's not letting me add rows. I'm stuck on like row 4. I'm trying to get a row 5 in there. How would I do that?
Press the down arrow key on the keyboard. Does that open it up?
No. Yeah, there we go. Got it. Thanks.
Uh-huh. All right, so I'll give you a chance to catch up here. But at this point, then I would put in, so I'm sitting now at 2. I'm going to be setting point 3. So notice after I finished setting point 2, because my backside was 270 degrees. That's due west. I turned an angle right of 180 degrees and set point 2. That's what line 6 says. And it went 100 feet out at a 0 degree zenith angle and set point number 2. Now, it assumes because I'm in traverse mode, I'm going to start adding traverse points. So that was point number 2. I've now moved up to my occupied point is now point 2. My backside point is the previous point, which was 1, but my foresight point is point number 3. And I'm going to say maybe, so I'm sitting at 2, looking at 1, I'm going to set 3. So that's going to be an angle right of 270 degrees because that's 2 looking at 1, turn all the way around, and I'm going to come down here and set a point due south of 100 feet. Same thing there. And this is going to be called control 3. The do appears that zoom extents. Okay. And so I could put this same thing. I'm now looking at 3, looking at 2, and I could set a bunch of stuff. Now, if I change this from traverse to say side shot mode, all right, so here I am at point number 3 and I'm backsliding, I'm looking at, so I was 1, I set point 2, point set 3. So 3 now, I'm looking at 2, which was up above here. So I'm going to now set a point. Let's go an angle right of 45 degrees. And let's go, say, 50 feet. And we'll call this one say it was a building corner. All right. And now I want to do an angle right of, say, 90 degrees this time. Also 50 feet. And we'll call that one that's also a building corner. And then let's do another side shot. Let's say instead of an angle right, we did an angle left of 40, and it's 50 feet. And that was say an offense. And then if we did, you can see we've got northeast, southeast, southwest, northwest. Those are the quadrant points. Azimuth, then angle right, angle left, deflection right, deflection left. I'm going to just go to my angle right. I'm still sitting at 3, looking at 2. So I'm still sitting here, looking here, and I'm just setting all these side shots. And it's 0.7 now, so I'm going to angle right. Let's go, say 100 degrees, 56 minutes and 25 seconds, 75.26 feet. And that might be, old. Well, it's called an IR found, iron rod found. Okay. So you see, everywhere I go now, I continue to compute these side shots. Now, when I'm through doing side shots, I'm going to, instead of this next, I'll switch back to traverse mode. And so now I'm still sitting at 3, looking at 2. And so if I do an angle right, this time let's do a 270. And let's go 100 feet, 90. And this is going to be CTRL-4. All right. So now see where we are. And now you see the different colors up here. I've got traverse points. I've got side shot points. And so now if I did, let's say go right up again, 270, 100 feet. And this is going to be control 5 equals control 1, because I'm checking back into that one as well. Don't have to put it there. That would be good. And then maybe I'm going to do an angle balance shot from here. Now, again, I've moved up to here. I'm looking back here. So I did a 90-degree angle right. And let's say we did 100 feet away for that one too. And then that was my original church spire, just because it was there. And that would be essentially it. That's what I did. So I started out here. I've got a closing angle balance right in here. So now this would all compute absolutely fine with no misclosure. It's all perfectly, legitimate and the same all the way around. Okay. But let's say, or let's go up here now, do a file save. And now we look what we've got and how we can work with this. If you select a particular observation, now this guy I can actually get rid of. Okay, so if I set on a particular observation of any type, you see what's happening down below is I'm seeing that light up. I can also, if I click, say, number 5 down here, I'm going to switch my icon up here to use this graphics pick cursor. So now if I pick item number 4, this line 4, it jumps me to the spot in the raw file where that observation was made. Okay. Now I clicked here at the start and it's okay, well, there are 2 points there. One's my 0.1 and one's my 0.9, which was that control 5 equals control 1, which actually I need to just simply say equals one, not by description, but by point number. That was my mistake there. So anyway, so as we're looking at these individual things, you can see where they are, or you can choose a given observation down below graphically, and it jumps you to the spot in the raw file where it took place. You can also choose to hide. Remember that display show and hide? If we show and hide, if we hide the side shot records, so now it says hide side shots, so we're going to show the side shots, and then I guess we have to redraw them with this icon here. Okay, so that turns on and off the side shots. If they're just thousands of little side shots and you only want to look at your traverse stations, then that will take care of those, turning those on and off. Okay. So now let's say we've made this record of our observations. Well, let's say the initial backslide we just assumed was 270, but then we found out that, well, that's actually, let's just change it to be 235. So that would then take that initial 235, but notice the 270 or the 180 right here, that still says 180. Well, maybe that was, what would that be if we went from 270 to 35? So 35, so 180 would be 215. Is that right? 215. Yeah, so now you don't see the original backside line here with the new version. The old version, it used to show you that line, and if we used a point, it would still give us that as well. But let's say that was initially just a 180. And then any of these things that we change here, and this is what happens to a lot of people that are doing these data collections. If you're doing total station work instead of GPS work, when you set up and occupy a point and you backslide another point, a lot of times people right up here will forget to set that circle out to 0. And it's not here in this file where you're doing it. It's on the instrument itself. You got to 0 the plate. And if you don't 0 that plate, it's going to take the reading that's on the circle and then take, the rest of these things in here. And so you're going to get these points where they're all in relationship to each other. They're all relatively the same, but they don't fit on the ground at all. I had a client that he would get this all the time where he'd start and stop his traverse work and he would forget. And he goes, well, they're all like that, but they look like there's some kind of weird rotation going on. And we could go through here and find where you need to, right there, you forgot to 0 your plate. We did that and it just rolls it right into place. And again, the advantage of this raw file processing is that it keeps a record of the observations. And if you need to change something in a setting, again, if I were to say these points, that would be like 5,000, 5,000, and whatever these compute to be. If I now come back a week later after I've researched where those points are and I've got state plane coordinates, I can put them in there. I can change my elevation. And then all of these things will recompute because my observations are still the same and they're still in my file. Okay. So that's the basics of all of that. Now you can also, let's go now, if you see how that kind of stuff works, and if here's an example of, let's go to this, let's go to this point number 9. Let's say instead of 90 degrees, let's say we went 89, 58, 30. Okay, so again, we didn't graphically see much, but that's my angle balance shot. Okay, it should have been 90, but it wasn't. It was close. And then let's say we're setting point number 3. So if I click here and I see here, there's my point number 3. It was supposed to have been a 270, but let's say instead of 270, we put that in as 200. Okay, wow. That really, so 1 to 2 to 3 to 4, 5, 6, 7, then 8 to 9, and then 9 sets this point down here, which should be this point over here. So that misclosure right in there, let's see, is going to be, if you draw a line here, you see this point at point number 2, I said 200 instead of 270. So to set point 3, it was this setup. And inside the figure of my traverse, if I draw a line that bisects that angle, that's going to be perpendicular to the amount of misclosure that I get on that. That's that find the bad angle stuff. But you'd have to know where it's supposed to wind up, and we don't. We're just going to a church spire. We don't have a point number to compare that to. Okay. So a couple of different tools here. We've got that misclosure there. Let's put in, say, 270, 270. Let's make this one, say, 270.0230. Okay, so we got a couple of errors as to what we should be. And we know that point number 9 and point number 1 should be the same point, but right there you can see, as I keep zooming in down here, you see that misclosure. So whatever made, and if you draw a line from 1 to 9, so whatever made that change, right there's my misclosure line, that 1 to 9, right in there. So a bad angle could be perpendicular to that. So that would be maybe if I had the 2 to 3. So at my setup number 3, and right there I can see I'm sitting on point 3. There's where that angle, it was a little too much. So that pushed this remaining set of lines up and away, and that set that distance. And if I had a distance that was too much, I would look for, if it was all in one observation, then I would look for that. Let's put this one back to say 270. And then let's make the distance to point number 2. Let's make it 105. Let's make it, something we can see. So now from 2 to 3, that should have been 100 feet, but it was 105. And you can see by the time I get back around to 1 to 9, you can see there's going to be a difference of 5 feet right there. And it's parallel to that as a busted side in my traverse. Whereas if I had a busted angle, let's just call that 272. So now my angle at this point, if I look at the misclosure here, that should find it to be, that line is going to be perpendicular to the bisector of that observation. Okay. All right, so now we've got this misclosure here. Let's set this distance as 99.96. All right, so we got a couple of little errors in here, nothing major. But normally you would have some errors that are evenly spread throughout. So now we got enough that's going to give us some problems. Let's go to the tools menu or I'm sorry, the process menu and choose no adjust. We're just going to do a raw computation. All right, so multiple measurements, which we don't have, but if we did, we're going to average those. We can average elevations and distances if we're using reciprocals on backsites. We didn't do any of that stuff. We just put in just raw Kogo type stuff. And so now my reference closing point, so I started at 1, went all the way around here. My reference closing point should be 1. And it knows its value there, and I'll say, okay. And now, here's how do I do my traverse. I start at 1, I end at 10. I can either choose it automatically based on the records, or if I choose prompt and say, okay, it's going to now show me, and I could come in here and manually control what's done, but the automatic works. I'll say, okay. And now let's see what we got here. We've got, for no adjust, we come down, here's my raw file, coordinate file, all these different items. Here's my closure results. Here's my starting point 1. And I've got an azimuth error here and a northing and an easting. What did I miscompute? Oh, sorry. My closing is not 0.10. That was my angle balanced shot. So if I go back to no adjust, my 1, and I'm going to go to 0.9 and choose OK. Now, there we go. Say OK, and now that's a little better. All right, so now I've got a northing error of 0.033, an easting error of 0.023, no vertical, and I've got, it's basically 4/100ths as a miss, 4 traverse lines, 5 side shots. I had 1 store point, totals, etc. And I've got a precision of 1 part in 10,000 essentially. And here's my raw computations. Here's my computed side shots. Okay. And it gives me a little warning here that says, 0.04, that exceeds my tolerance. And it happened at this line 13, occupied 0.8, slope distance of 100, horizontal angle of 270, zenith angle HIHR. So that was that closing leg. That was my angle balance shot. And that's where it's finding a lot of that error came into play. I could then choose an angle balance process again. I'll go from 1, it's my reference closing point. I'm going to go from 1 to 9. So now the measured closing points 9 to 10. And the measured balance, see if I can. I can't do it with this because I don't have another known point out here for 10. To set that up. So 9 to 10. I'm going to pull out this. Let me cancel that. 9 coming into 9 is There should be a close. There we go. So 8 to 9 should close my traverse, and then 9 to 10 should be the angle balance. Now let's try that. First, my no adjust. My reference closing point is 1 to 9. Yeah, there's my same precision, so that should have worked. Here are my computed coordinates. Okay, and right here's my checkpoint. Remember I said that point number 9 equals 1? So it said, here's my reference point 1. Here's my measured point. So you see there, see that equals 1. And that's the difference right there, 0.0328 in northing and 023 in easting, which is a distance of 4/100. It says it exceeds the horizontal tolerance. That was set. If I look at my process settings, my horizontal tolerance of, well, these for the measurements, not for my, right here's my checkpoints tolerance 0.02, and it was 0.04. So it was past what I had set there. And that's just a report, okay? So I'll go back to process now and choose an angle balance. And this time, we'll do point number 1. It's going to go 1 to 9. So 9, it's still 9 to 10. Let's say 1 to 10. And the reference angle, so azimuth at 235. I'm not sure I'm getting these numbers correct here. So yeah, so that gives me an angular error of 1 minute 30 seconds. And you see right there, I had 89 degrees, 58 minutes and 30 seconds. So it picked up that right quick. See, my closing azimuth should be 235. It computed as 234, 58, 30. So that now should come into this. And if I apply the angle balance, here's what it does, is it, again, up here's my raw misclosure. And I now have these observations, my side shots. There's my checkpoint. So all of that was exactly like you saw before. Now the angle balance is it takes this angular error of 1 minute and 30 seconds and it spreads it across all those 5 side shots, or I'm sorry, 5 traverse sides. And it adjusts each angle by 18 seconds. So that's this 1 minute, 30 seconds per 5. So 18 seconds each. And now my closure results after I apply that angle balance would be 5,057, 49,981 instead of up here, which was 5,033, 49,977. This would be that. And my closure then would be, where's my closing point? See, it's actually gotten a little bit worse at 0.06. Where was my, oh, it's right here. I was looking for this. 1 part in 66, 61.1, but my raw closure was 1 part in 99.99. Okay. Now, usually what happens in true traverse numbers, when you do an angle balance first without doing an actual adjustment, all it does is applies the angular misclosure throughout all the observations, and then it keeps the distances all the same. Okay. And it normally will tighten up the closure on a traverse by making the angles, taking out the pointing errors that you're going to get just as random systematic errors in the set of observations. Now, it's not doing it for us because we introduce a specific large error in one particular setup. Okay, so that's what generated our particular stuff. So the angle balance didn't really improve our situation, and we could use that sort of front run tools here, first of all, with no adjust, and then with the angle balance to see what happens. And then we could, at that point, decide, okay, well, now let's use a compass rule adjustment, for instance, which is those different, whether it's compass, crandall, or transit, is going to be based on whether or not you feel that your angular measurements are more precise than your distance measurements, or vice versa, or that they're even. And so I would say my reference closing point again is point number one, all of the different settings. And then right here, I'm going to not apply the angle balance, but I want to spread that out. And then we could go from there to there, 1 to 9. It's good to go. With that, here's now that one part 99.99. And then after I do the adjusted elevations, of course, are the same as they were. Here's my checkpoint. There's that 0.04. And now after I do my compass closure, it's now, if you look at 0.2, which was 50.81.915, and it's now 50.81.921. Okay, so these are after it has applied that compass rule adjustment. In my maximum adjustment amount of 0.04, my starting point. So here now are my new adjusted coordinates down below here. And of course, the side shots don't adjust other than when point number 3 gets adjusted and point 2 and 3 are adjusted, then it still applies those same raw angle and distance measurements to compute those side shots from there. Because there's no other checks on those. Those are just kind of hanging on, dependent on the occupied and backside points that set those. Okay. So that's where we've typed in this information. And then we could, let's say we'll save this raw file. And then if we were to, well, we can get some summary reports. And we've got the report on coordinates 1 to 10. Let's see anything there. So that's just basically listing the points. And we could list our raw data. Again, the same deal, just like what you're seeing in the raw file itself. Okay. If we were to exit this or close this file, it would then prompt us, do we want to save these coordinates as it's computed based on all these different things that we've done? And we would say yes or no to that. One other thing that we've done here that I haven't talked about, I don't have a set to show you, but control coordinates, if you can set a control coordinate file. Let's say you've got a bunch of control points in your area that you're working with, and they start with, say, 0.101 and they go up through 0.125. Well, if you set that file up to use that as your control, then up here in this information, You don't have to enter point records. You don't have to store point number 101, point 102, point 103, point 104. And to put those coordinate values in, you simply come down here and start putting in a backsite record. You'd say occupy 102, backsite 101. It knows because you've pointed it to a new control file to go and look in that file for those values, set those up as starting conditions, and then compute going forward. Okay. So a lot of times, particularly if you're not doing the traverse and you've already done your traverse and you've got your control points, you're at this point just establishing, all of the side shots along the project. You're picking up, all of the planimetrics and topographic work on the shot of the site that you're working on. And you can do all of that with basically just with side shots. And you're pointing it to that separate outside control file, but you don't need to bring those points into your file. You don't need to do anything with it other than just point it to that file. And then when you refer to them by point number, it looks in that file for those point numbers and reads their values and goes from there. Okay. And let's see what else. If we open a raw file, let's open this raw file 1, and you can see from here, so you had this point 1, 5,000, 5,000, a backside record of 1, 270 degrees. As an azimuth, I zeroed the circles. There's my traverse. I've got a closing shot and angle balance shot. And that's very much like what you just saw us do, except we had some side shots and things in it. And right there is the busted angle and the busted distance down here at this point, where we are sitting on 3, looking at 4, and we missed those by a little bit. And then that would be what caused the misclosure up here, where 5 and 1 are supposed to be the same. So traverse 5 equals 0.1. Okay, so that's the same thing there. Let's open up another raw file. This time we're going to use a real raw file. Okay, this one should be considerably more. And as you can see, these are things that came out of a, out of a data collector. And it's got all of this sort of description records up here, 2 store points, 5,000, 5,001. You see my coordinates there. They were put in traverse, PK nail. There's another description. It's got my temperature, pressure. I've got an HI record, which put in my 5.47 HI. I've also got a rod height if I had them set here. You may see those later. And again, I've established my backsite by sitting on 5,001, looking at 5,000. I zeroed out my circle. And here again, now I put in an HI, which is, now before I put in the 5.47, but at this point, I now have a rod height. Even though this says HI, that's what you're putting in is both or either of those 2 values. So I could have put this 495 right up here and then not use this down here at all. Okay. But this is another thing that is quite often, or not necessarily quite often, but it sometimes is overlooked, or you forget to change the rod height because we're so used to using a fixed rod height on our reflectors. And if you forget that, then it's going to miscompute some of your points. And if you can find where that happened and recall what it's supposed to be, then you can come back to your raw file, fix it, and just recompute everything. Now this looks like a bit of a mess. Let's turn off my side shots. And there now you can see it's not quite so bad with those things on and off. And if I look at this, there's my 5,001 to 5,006. Looks like it was done there. Here's now 5,001. And it's going to set 5,002. So 5,001, that first backside was 5,001. It's looking at 5,000, which is way over here. And it sets 5,002. Okay, so there's 5,002. I traversed from 5,001 to 5,002. The back sight was 5,001 looking at 5,000. So that was this line over here. It's at an angle right of 125, 53, 56, 185.57. The zenith angle, and set my traverse of that. I go up to my next one at 5,003 to 4 to 5. And now it did not go to 5,006 next. It went up to, here's a closing shot angle balance as well. And it set 7,001, and that was over here equals 5,001. So that was my check-in point. Okay. And then I had a couple of other little side shots and things that I computed with the rest of this information. Okay. And let's see, the other thing is, by the way, what you're looking at here, these are what are called closed figure traverses, which means that they form a closed geometric figure that you know certain things about. The sum of the interior angles should be 180 degrees times the number of sides minus 2. Isn't that right? N minus 2 times 180. Let's say 180 times 2 is 360. So 1, 2, 3, 4. Yeah. So N minus 2 times 180 would give us the total angle values that we should sum that up to be. Those are all well and good, but here's a bit of nomenclature just to be aware of. When you say a closed traverse, or when you see that term closed traverse, that does not mean that it forms a closed geometric figure. Sometimes they do, but that's actually not the best way to do a traverse. A closed traverse simply means you start on a known position and you end up on a known position. That means you close to a known location. And it's that misclosure, it's how much you miss that point when you calculate up all your observations as to what it should be. And there's a reason that that's actually better. It can catch one additional condition. And I'll show you what that is here in just a second. I'm gonna go ahead and just exit this, and no, I'm not gonna save those. I'm gonna show you something real quick here. Let's just set this to be, this will be my all right, so if this were my traverse figure that I had observed out in the field, okay, and I'm going to now, oh, shoot. I meant to do that as a, so entity, line lines, let's just join list. All right, there we go. So I'm going to copy and I'm going to scale this. There it is. Like that. Now, here's the problem with traversing to a closed figure, even though that's what we often do because we don't want to say start way over here, work our way around to some point and try to, we're chasing control that we might not necessarily need. But here's the one thing that a closed figure cannot compute for you. And I had this happen on a real job. I was working on a landfill and it was something like say about 6,000 acres total. And the photogrammetrists did the base mapping that we used to do our work. And we're going out there at the end of our project. We're starting to, try to go out there and, stake out some points and put in our final cell locations and such like that. And we were missing things by like 1.5 feet out on the other end of our project. And I could not figure out why on earth. I got a hold of the photogrammetry firm. They said, well, here's what we got. And they said, well, give me the control. What did you use on your ground control to establish the control for the photographs from the aerial photography? And so they sent me up this information, and it was this closed figure, and it all looked good. Everything was tight. It fit itself very nicely. So we couldn't figure it out, couldn't figure it out, couldn't figure it out. And then finally it occurred to me, well, what was going on was the surveyor that ran the control that should have looked like this. His instrument was out of calibration and he had a scaling error in the distances. His angles were nice and tight, but his distances were off. Now, let's say we change this to show it not quite so drastic. Let's say it like this. We're going to go here and we're going to say 1.99. Okay, let's undo that. Let's make it 1.75. Yeah, a little bit better. Okay. So his distance meter was, his total station was, it had a scaling factor. So it's reading the distances to be only a certain percentage of the true length that it should have been. This is what should have been. So when I get out to here, that's where my location out here should be. That's what the mapping should have given me. That's what the ground did give me when I surveyed it locally. But the control that was run for the photogrammetry said, okay, I start here, do all my traverse, and I close up, good closure. I adjusted, everything's fine. And it said this was it. And so you can see, though, that it thinks this point up here is what should be out here on the ground. It computed it to be out here. Same thing, this one to this one. Okay, so everything was off. And if we start at the same starting point, by the time we get back around, we close back on the same starting point, but we never pick up the fact that our scaling is off. Okay. So that's why I like to always start on a couple of knowns, like so. If I have, let's say, point like that, and then so let's say now my traversing might start here, backside here, and start turning around, and I'm going to do, wherever I go, and then I'm going to close into this point, and I'll sit here, and I'm backsiding here, and I'm going to turn this angle around and compute this endpoint down here at the bottom. And so now if I have a scaling factor problem, and that was at 1.75 5 or 25% less or 12.5% less. So if I scale this one now from here, and that was at 87.5%, so 0.875. So now when I compute all the way around here and I close in here and I measure this and I shoot that last distance, but that point should be there and I miss it. So even though all of these measurements in relationship to each other are good, because I start with these two knowns over here and I end on these two knowns over here. And if I miss that right there, that has picked up that scaling problem. Okay, it's not an angular problem. The distances are all relatively okay. But that, and that would still be a closed traverse because it closes on known coordinates. It doesn't mean that it's a closed geometric figure like the other examples that we show. So that's the ultimate way to do your traversing. Always end up on two known closed, two coordinate values other than the two you start from. That's the best way to do it. I know we often don't do it because we don't have control, right there on top of where we're working, and we can't go chasing this stuff all the way across the county. I'm sensitive to that. I'm aware of that, and you can't run a survey business by chasing all that stuff down. It's just absolute best practice when you, well, let's put it this way. If you work for the federal government, right, you work for the Bureau of Land Management, you can do that. Had a seminar that I was part of when I was in college. I went to the seminar. I was the president of the student chapter of the American Congress on Surveying and Mapping. So I went to the seminar presented by Walter Robillard, who was one of the country's premier boundary retracing experts. I'm sure you guys have probably run into the name. And he was talking about a job he did once down in Georgia. He went down there and he computed where the point was supposed to be. He's out in the middle of the woods. The deed called for a particular, like an 8-inch cherry tree, and he couldn't find it. And so he dug up the top, pulled all the dead leaves and stuff off around the ground. He found this, 4.5-foot diameter circle of discolored clay. He then sampled some of that clay, sent it off to a testing lab. It came back and it found out that there was ash in it, and the ash turned out to be from burned cherry trees. He computed from an 8-inch to a 4.5-foot diameter, and over the number of years since the deed was written, that he concluded that that was in fact the tree. He then went to the center of the discolored clay and established a point. Well, yeah, that's all well and good. And one of the surveyors in the room asked him the most cogent question of the day. He goes, "That's all great, sir, but who pays for that? My client's not going to pay me to do that. And he's not going to wait for the time it takes to get the test results back." And so at that point, he goes, "Well, yeah, you're right. I happen to enjoy the luxury of working for the federal government where, it doesn't matter if we're late, and it doesn't matter what it costs." So I am aware of that, but just so you know, that's sort of some of the thinking that you have to sort of stay aware of when you're working with these measurements as to what's actually a little bit better. All of that goes right out the window when we start using GPS and we're using satellites and we're using broadcast corrections. And so everything else is already sort of pre-done for us. But that's the gist of that system, of that raw file processing. And here's another thing that you can do from that. So let's say we have a situation like this. Go ahead in your drawing file. Let's go look at our points. If we have any points, I don't think I have any in mind. You can erase them. Yeah, we got 0 points. All right, so if we do this, I want you to draw a 2D polyline. I'm going to choose OK. I'm going to click down here. I'm going to type D for distance, which is down here on my command prompt. So distance of, say, 123.45 feet. And what direction? Well, I want to go to a cursor angle pick or at a given angle. I'm going to go of angle. And now I have a code of 1 through 9. What are my codes? They're right here. Well, I'm going to use that as an azimuth. So I'm going to say my angle code is going to be 5. And the azimuth, I'm going to make it at 45 degrees. So it went from where I started 45 degrees up to that point. Okay. It now wants me to pick another distance. Well, I'm going to say Q to quit to get out of distance mode. And now I'm just going to pick a few points like this. All right, so now I've got something with relatively 100-foot-ish sides on it. Okay. Now, let's go to our COGO menu, coordinate geometry menu, and let's create points from entities. And it's down toward the bottom. This is how you would gather up points for things in a file that you need to go out and stake out. You could do a draw locate points and snap to the endpoints and do all that kind of stuff, or you can simply create points from these entities. And I'm going to say, call it this. I will draw the points so I can see them. Excuse me. And oh, let's just keep all those defaults the same. And my descriptions are just going to be PT for points. Very clever, PT. And I'll say, okay. And I'm going to process these particular entities, make sure polylines is on. That's what that is. And I'm going to come down here on my curve. I'm going to skip any radius points and midpoints, which there's no curves there, but that's fine. Avoid any duplicates with existing. All that's looking good. I'll say, okay. I'll now click this and hit enter. And now I've got 1, 2, 3, 4, 5, 6 that were taken from that entity. So there's now a bunch of points. Okay, they're all at 0 elevations. We're not going to worry about elevations at this stage. All right, now we're going to go back to coordinate geometry and we're going to talk about some things here real quick. There's also this draw locate points. And you see that parentheses LP? That's the shortcut. I can type LP on the command line. For inversing, I can type I on the command line. I can set an occupied point by typing OP. You get the idea. Okay, and that draw locate points is the very same command as points draw locate points, no difference. Right. So I'm going to do a traverse. For instance, I want to traverse I want to sit on point 2, I want to look on point 1, and I want to set a point 101, for instance. Okay. Or I'll tell you what, let's just continue the field. We're going to sit on 6, look at 5, and we'll set 7. So if I traverse, notice what it's asking me. Pick a point or a point number, but read the line above. In fact, 2 lines above. It says running traverse, lines are off, raw files are off. And I'll show you that in a minute. So our occupied point, it's asking me to tell it. So I'm going to say I'm going to be at point 6. Okay. Now, so where am I going to go from there? If I'm at point 6 and I do an angle bearing code, now my angle right, my 1, 2, 3, 4, those are the quadrants. 5 is the azimuth. Then 6 is angle left and 7 is angle right. 8 is deflect left, 9 is deflect right. So I'm going to say 7 is my angle right, but it wants to know, pick a point or point number. It's asking me for my backside point number, right? Reading the line above. So I'm going to say, all right, that was point number 5. Okay. Now let's just go to a point, let's say 45 degrees, and it's 100 feet away. Vertical angle type, I'm going to say 0, so it just computes it, and I'm going to put it TR-7. Okay. So now there is my 0.7. I was sitting at 6, looking at 5. I turned 45 degrees, 100 feet, and set that point. And now if I keep going, let's say I do a 7 angle right again. See that little graphic right there? It says, okay, you're sitting on 7 and you're looking at the previous occupied point. So now my angle right, if I go, let's just go 90. And let's go 50. And we'll call that one TR8. Okay. And now I can just press escape to finish. And so I've done some traversing. I've done that 1, 2. Well, I had 1 through 6 already done, but I then traversed from 6 to 7 and to 8. Okay, but I had to read my prompts kind of carefully and figure out where I was in terms of occupied and backside. But here was that little trick I was telling you about earlier. Let's say I want to do some more traversing now, but I want to sit on 0.5 and I want to backside 0.1. Okay. And I'm going to do some computing, either traverse or side shot, either way. And if you do traverse, that means it keeps moving you up. If you do side shots, it holds you where you are. So I could go to that Koga menu and I could enter an occupied point, okay, right here. And then, do that before I set these up. Now I'm going to also do right here my raw file on and off. I'm going to turn that on. I'm going to toggle it on. And it says this causes traverse, side shot, inverse, and draw locate point commands to write a new file. So I'm going to say, I'm going to append this file and I'm going to call it test raw file -2, whatever. It's going to be empty. Sorry, it's not. I've got to raw file on and off. I'll make a new one. Sorry, that was the problem. Test raw file 2. Okay. So now that raw file is there and it's going to start collecting stuff that I do. If I also turn on line on and off, notice there's a check there now under raw file. If I turn line on and off, it's ready to go as well. All right, so I'm going to, remember, I'm going to sit at 5, I'm going to backslide 1, and I'm going to set some things up. So the first thing to do in this little shortcut is to establish that occupied and backslide pairing. And that's going to be very quickly. I'm just going to type I to do an inverse. And I'm going to go from 0.1 to 0.5. Okay. So that reads me that information, and I may or may not even be interested in it. I don't care, but look what it's got me set up to do. I can now do a T for traverse. Okay. You see that little graphic? It's already recognized that I went from 1 to 5. I'm now sitting at 5, backsliding 1, so I didn't have to worry about doing that. I'm going to again go angle right, and I'm going to go, say, a 90 degrees to that. And I'm going to go 100 feet. And that one's going to be TR9. And now notice the line drew as well. So if I keep going now, I'm sitting at 9, looking at 5, and I'm going to go an angle right again of 90. And I'll go another 100 feet. And that's going to be TR10. All right, there it is. And now I'm going to type side shots. I'm going to just type an S for side shot mode. Now I'm sitting at 10, looking at 9. Oh, let's see, what do we want to do? If we're sitting there, let's go an angle right at 270. Let's go 25 feet. Just call that side shot point. There's point 11. No line drew because it's not a traverse. And I'm still sitting at 10 looking at 9 because I didn't traverse. I'm in side shot mode. So now I'm going to go 90, 25. Oops, I'm sorry, angle 7 is 90, 25. Side shot point as well. So there's number 12. Now there, let's go 180, 25. Side shot point. Okay, and now if I do a T for traverse, I'm going to go, let's make it 135 degrees, 125 feet. And that's going to be TR dash 11. Hit enter and then escape. Okay, so that's what's turning on line will automatically draw lines between points when you are traversing. It doesn't draw them for side shots. So now, if we look at our survey menu, edit process, raw data, and we open that test raw file 2, there's our initial 5 occupied, looking at 1. It read the azimuth, it set the 0 on the circle. I traversed up to points 9, then 10. I'll turn on my side shots there. It computed these values, okay? And then finished with that last one, which was my TR11. Okay. So this tracked everything, and maybe I put in a number wrong in here. It lets me have that handy and go back and retype the number as to whatever it should have been, recalculate the points. So instead of 135, maybe that was, I was dyslexic and it should have been 153, so it recalculates that point. We can then save, and then we'll go ahead and just exit this and let's see here, set class example 1. Didn't. So 153, that was so to calculate. Yeah, save my coordinate file. That's what I missed there. Did not automatically save that. So now when I compute that, you see what it says? The screen point differs from a coordinate file by, well, considerable amount, 39.109. I'm going to use the coordinate file, okay, because instead of 135, it was 153. So that let me recompute that and notice, now why did this line go with it? Remember our Carlson configure link line work with points right here. Okay. So all of those things helped that process and all of these computations. Let's say I knew that, oh, I put the wrong error, I put the wrong angle in there. I can go back to the raw file, recompute the coordinates. It saves it in the file. It didn't change anything out here yet until I went to find it. I could have redrawn the points. It would have taken care of that for me. If I knew that they were different. So I'll just do a new, draw locate and go from there. Okay. Questions on any of that to this point? It's time for our mid-afternoon little break. Everybody
I'm
good?
good.
Okay, sounds good. So we've got some good things on computations and coordinates. Then we're going to come back and start looking some of these tools as to how they actually apply to what we're doing and start getting into some field to finish. So what I will do, let me pause our recording.